Okay, good morning all. Right, so today morning we'll continue with the maths. Okay, so last time we did 2023 paper, we did up to 28. Okay, so today we are going to do first 2022 paper, then at the end of 22 paper, we'll come back and do the rest of the 2023 so that we can start from fresh. Okay, right, so let's move on to question number one. Multiple answers are possible. Okay. 40 questions. So make sure you manage your time. And if there are difficult questions, just skip those and proceed. Okay. Come back later and do those. Otherwise, you will waste your time. Right. Question number one. Consider the statement if n divisible by 30, then n is divisible by 2, by 3 and 5. Right. If n is divisible by 30, that implies n is divisible by 2 and n is divisible by 3 and n is divisible by 5. Is it true? Is it true? Yes, because 30 is divisible by 2, 30 is divisible by 3, 30 is divisible by 5. Yes. Whenever n is divisible by 30, it is divisible by 2, 3, and 5. Right, correct. Which of the following statement is are equivalent to the statement? So basically this means and, okay? And if n is not divisible by 30, right? If n is not divisible by 30, uh, n is not divisible by 2, not divisible by 3, not divisible by 5. Can we take something like that? Just because n is not divisible by 30, can we say that it is not divisible by others? No, right? For example, if you take 10 is not divisible by 30, but still it is divisible by 2. So I will say no. If n is not divisible by 30, n is divisible by 2 or 3 or 5. So I don't think we can say like that also. Just because n is divisible by not divisible by 30, can we say that it is divisible by any of these? There can't be. There can be, for example, a prime number is not divisible by 30. And of course, that prime number is not divisible by 2, 3, or 5. I will say no. If n is divisible by 2 and divisible by 3 and divisible by 5, then n is divisible by 30. Can you say like that? So that means other way. So whenever x implies y, can we say y implies x? But maybe this is a special case, right? If n is divisible by 2, 3, and 5, n is divisible by 30. Can we say like that? Can we say like that? Just because it is divisible by 2, 3, and 5, can we say it's divisible by 30? That is bit of debatable one for me. If n is not divisible by 2 or not divisible by 3 or not divisible by 5, then n is not divisible by 30. That is a tricky question, right? Not divisible by 2, not divisible by 3, not divisible by 5, then n is not divisible by 30. Okay, let's keep that also open. If n is divisible by 2 or 3 or 5, n is divisible by, that is definitely no, right? Just because it is divisible by one of these things, we can't say that it is divisible by 30, right? So maybe one of these two should be correct because usually we need at least one correct answer, right? But I feel like this is more likely. If n is not divisible by 2, 3, and 5, because those are factors of 2, 3, 5. So most probably it will not divisible by 30 also. Because the LCM of 2, 3, 5 is also 30. So I'll go for C, but most probably answer is C or D. I'm not very sure why C is not correct, but it looks like yes, D is also correct. Right? That is why I told you that more probably C and D. but I went for C, but examiner's answer is D. I think D is correct. It makes sense. Okay, it's purely you need to think logically. Okay, but I don't know why C is not correct. Okay, not correct. If now ChatGPT says A and D are correct, that is you can see ChatGPT also has messed it right. So ChatGPT says A and D are correct. Examiner says D is correct, but I feel like C and D. C is also correct. Anyway, let's keep that open for the time being. Right, so let's go on to 2, and we can think about it later also. Right, if x plus x 1 over x is 1, then the value of this, So if you square it, there's a possibility of we are getting this term and this term, right? So therefore, let's try to square it. So x plus 1 over x square, which is 1 squared, that is x squared plus 1 over x squared plus 2 times x into 1 over x, which is 1. And you can see x get cancelled. So therefore, x squared plus 1 over x squared equal 1 minus 2. 1 minus 2 is minus 1. What we need is x squared plus 1 over x squared plus 5. So then I need to add 5 here, then add 5 here. 5 minus 1 is 4. Right, I'll go for B. Second one, I'll go for B. Yes, B. That is this is a very popular, right, repetitive type of a question. Okay, so if you have done past papers, lot of past papers, you have seen these kind of questions. Right, next one. Anyone got a chance to have a look at this and got an answer?
Excuse me, sir.
Yes.
I took as 3 to power 3 and 9 as 3 to power 3. Sorry, I took as like 27 is 3 to power 3 and 9 as 3 to power 2.
Without considering the base.
Yeah.
Okay, so log 3 to the power 3 is 1.431 and log 3 to the power 2 is 9. Sorry, log 3 to the power 2 is what we want to find. Okay, so then you wrote this as 3 to the power 2 into 3.
No, sir. I divide 1.43 by 3.
Yeah,
Again.
yeah, that is what is being by you. I think your approach is correct.
Um,
So 3 to the power 3, you can write it as log 3 to the power 3 into 3. Sorry, 3 to the power 2 into 3, which is 1.431. So then multiplication is,
so I divide 1.43 by 3
why do you divide? Because
because
these three we can take the, I think your point is correct. So that means you take these 3 because power you can write it as multiplication. So 3 times log 3 is 1.431, right? Your logic is correct because a to the power n means n times log a. So then log 3 is what we need. Sorry, not log 3, right? Then you can write log 3, right? Then log 3 is 1.43 divided by 3, right? So then you have the log 27 and log 3. So let's
log 9 is 3 to power 2, no, sir.
okay, so let's divide this one also. I'll take the calculator. 1.4343 divide by 3. That is 0.476 or 0.48. Right?
Yeah, that is for 3.
That is log 3. Now what we need is
Yeah.
log 9.
9. 9 is 3 to power 2.
3 to the power 2. That you can write it
So
as 2,
log,
2 times log 3. Because
yeah.
we have
So
the log 3, then
0.47.
2 into log 3 we have 0.476. So that means 476 into 2. I think your approach is correct. Okay. So 0.476 into 2, that is 0.9533. Is that your answer?
0.95.
Yeah,
4,
9.
sorry.
Yeah, 954. Yeah, maybe 954. Okay. Right. So is that, I think that approach is correct, right? That approach is logical. So what is the answer given? Yes, A. Right. So that approach is correct. You don't need the actual base,
Okay,
right? We don't need the base because we can write log 27 as log 3 to the power 3. So then we can take the 3 out. 3 times log 3 is 1.43. That then we can calculate log 3. We don't know the base. We don't care. So then what we need is log 9. Log 9 we can write as log 3 to the power 2. That is 2 times log 3. Now already we have the log 3. So therefore now we have the value. I think the approach is not, I think the approach is correct. Approach is perfectly correct. Okay. So therefore answer is 2 times 0.476, 0.954. Yes, correct. Okay, correct. Right. So that is a tricky question. So that means you don't need to actually you are not supposed to assume because they have not given any base. Right. Even you assume, I don't think you can do this without this approach. This is the only approach I can also think. Okay. Right. So the next question. So they have added two tricky questions to the front. Okay. Right. Next one. A and B are two non-empty sets. Uh, this equal to, right? B intersection. Let's first apply, or maybe we can shade this also. Or first we'll apply the De Morgan rule and see whether we can get something. Otherwise, we'll shade it. This is A complement intersection B complement. Right. And here we have B intersection B complement. B intersection B complement is 5 because belong to B and not belong to B. 5. And 5 intersection something is always 5. So therefore, for me, answer is empty set. But let's shade it and also double check. Okay. Let's shade and double check also because by expansion I get 5.
So how to apply De Morgan rule for that?
A union B complement is A complement intersection B complement. That is De Morgan rule. A union B complement is A complement intersection B complement. And other version is A intersection B complement is A complement union B complement. So two versions of the De Morgan rule. That is one of the rule we discuss under sets algebra. Okay. Right. So let's look at the second approach also. A union B complement, that is this, not belong to A union B. Intersection belong to B. So it must belong to B as well as belong to A union B. So that there's no intersection, right? Intersection means double cross lines. There are no cross lines. So therefore, definitely the answer is C. I double check two ways, graphically as well as using rules. Answer is C. Okay. B. Right. So this is easy one. Just basic indices. So negative index we can write as 1 over positive index, right? 1 over half to the power half. So that means 1 to the half to the power half means 1 over root 2 because the answers are in root 2. That is 1 over 1 divided by root 2. That is basically root 2. So double check other answers are correct. Can't be 1 over root 2, can't be minus root 2, can't be 1 and so on, right? Answer must be B. 6-1. Which of the following statement is are true if the domain for all variables consists of all integers? Which of the following statement is are true if the domain for all variables consists of all integers? So that means your domain is integers. Right? Your domain is integers, that is minus 3 minus 2 minus 1 minus 0, 1, 2, 3, and etc. It's infinite set. Right? So that means this must be true for all integers. Right? All integers. All integers, so all n squared is greater than or equal to 0. That is correct, right? For all integers, when you square, the value is greater than or equal to 0 because even 0 squared is 0. So equal mark is there. All n, so n means integers. N squared must be greater than or equal to n. Is that correct? So when you square, when it is 0, 0 is equal to 0. In all the other cases, like 1 is also equal to 1. That is also covered. Other things like 2 squared is obviously greater than 2. 3 squared is obviously greater than 3. Right? And you can't have fractions. Right? Even minus 3 squared is greater than minus 3. So for me, this is correct. Anyone see that this is not correct? Any contradiction for this? Because it worked for 0, it worked for 1, and it worked for any other integers, positive and negative. I don't need to consider for fractions because this is integers. Right. So this one, exists n such that n squared equal to, no, n squared is 2 means n is root 2. Root 2 is not an integer. So there's no integer where n squared is 2. So therefore I say no. Exists n squared is n. Yes, there's one value. Actually, two values. 1 squared is 1, 0 squared is 0. Both are integers. Right? We discuss about the different classification of numbers. So 0 is integer. So this is correct. Exists at n squared is less than 0. No, right? No integer, when we square it, has a negative value. No integer exists like that. So therefore, I'll go for A, B, and D. A, B, and D. A, B, and D. Right. So here you need to check whether which of the following are tautology. Again, try to use common sense. If not, we have no other option but to prepare the truth table. This is a time-consuming question. Right? Time-consuming question. But let's see whether there are obvious things. Right? POQ implies P. Can we always say that? Use your common sense and someone tell me, is it always true? Anyone?
Yes.
No. Yes. Always true. I need a bit of explanation also. Anyone agree? Bit of explanation. Disagree? Bit of explanation. Tautology, right? Tautology means for all possibilities, this must be true. Remember, POQ is P. Now, when P is true, Q is false. Yes, P is true. But there's possibility that Q is true. P is false. Right? P is true, Q is false. So still you can say P, now remember Q is true, P is false, right? So then can we say that this is correct? Because POQ implies P. But this is true. But this is false. Because POQ is true, because Q is true, but P is false. So that means true implies false. So that is not going to work, right? Because true implies false means our logic is wrong. So I found one scenario where this is false. So tautology means this is always true for all P and Q values. But when P is false, Q is true, this is false because P is false. So therefore, I will not take this as a tautology. I try to use my common sense because otherwise it takes more time. What about this? P and Q implies P. That is a tautology for me because when both P and Q is true, always P is true. Because when both P and Q has happened, obviously P must have happened. That is why we say P and Q. Right? For me, this is a tautology, but this is not a tautology anyway. I'm just going. I try to preserve a bit of time. Okay, but other things I can't do like that. What about this? Maybe POQ. So that means POQ has happened. POQ has happened, right? And not P has not happened. POQ has happened and P has not happened. If P has not happened and POQ has happened, then Q must have happened. Definitely Q must have happened, right? So just use the common sense, right? This says POQ has happened, but we know that P has not happened. So if POQ has happened and P has not happened, definitely Q must have happened. For me, this is a tautology. This is a tautology. Okay. So let's try to do that because otherwise it takes more time. What about this? Whenever P happens, Q happens. Whenever P happens, Q happens. And Q has happened. Right? Whenever P happens, Q happens. Q has happened. But can we say that therefore P has happened? No, because there can be situations where Q happens due to other reasons also. Right? So just because Q has happened and because P implies Q, I can't say P has happened. This can be tautology or not, but I can't definitely say it's a tautology right now. So therefore, I want to check this. I want to check this, okay? Right. So I eliminated this. I took these two. Let's see whether my gut feeling is working. Right.
Sir, I don't think D is true
Which one? D.
because D.
D means this one.
Because if yes,
Yeah. What is your logic?
if P is true and Q is false, the outcome will be false.
But if
But
P
it's
is,
not equal to P.
no, but if Q is false, then this is false. But this says when this is true, this is true. So this X implies Y means when X is true, Y is true. But if Q is true, this statement is also false, right?
Yes, sir.
Okay. So therefore, we look at the situations where this is true. What I'm looking at is whenever this is true, we can always say, can we always say that this is true? Okay. Right.
Got it, sir.
Yeah. So therefore, this is, I want to double check. This I want to double check. What about this? Whenever P happens, Q happens. Whenever P happens, Q happens. That is what this argument say, this logic says. And P has happened. If P has happened and whenever P happens, Q happens, then Q must have happened. Right? So therefore, I'll say this is tautology. Okay. So I will say this is not a tautology. These are tautologies. But this one I'm a bit of confused. Therefore, I want to prepare. Actually, ideally, you must prepare truth table for all five. But it will take a lot of time, right? That is why I told you do these things at last. This kind of question, not all logic questions. This kind of questions, okay? But now I will check this one. P, Q. Anyway, this is the formal way. Ideally, you must use this approach for all five answers. Right. So I'll go for P implies Q. True, true, true. True, false, false. False means true, false means true. That is truth table, okay? That truth table, I explained how we get it in the class. Right. So now I can write Q and P implies Q. True and true is true. False and false is false. Okay. False and false is false. True and false is false. False and true is false. Now the big one is this implies P. Right? This implies P. So I need to look at these two. True, true, true. False means true. False means true. False means true. So all are true. So it looks like this is not. It looks like it's a tautology, right? Because direction is important. True, true, true. When this is false, anyway, it is true. So therefore, this is a tautology for me. This is a tautology. So then I will go for everything other than C. right? I only use the formal approach for this one. Other things I just went by my gut feeling also, which is very risky thing to do anyway. Okay. So for me, everything other than C. 7. B is not a tautology. That is strange. That is the only one I checked formally. Right. So that means I have made a mistake because that is the only one I check formally and I have made a mess of that. Right. Let's double check.
Yeah, sir, the third part is wrong.
Third part means third row.
Yeah,
False implies true. This is true. P implies Q is true. Then Q and
and the final part.
Q and P implies Q is this is true, right? Yes, so this is true. So this is true. So then true implies false is false. Yes, true implies false is false because true implies false is false. So therefore, this is not a tautology. Actually, my original conclusion was correct. I thought I have no sufficient information to say that this is tautology. Actually, and finally we found that it is not a tautology. Okay. Anyway, that is my mistake that I just have not prepared the truth table properly. Okay. Right. So you can see if you can argue like that, you can preserve bit of time. But again, at the end also, if you have time, prepare truth table also, right? If you have time, because we have 2 hours. Because usually maths paper, 2 hours is enough. I don't know, for me, right? Right. Right, eighth question. The meaning of the proposition x is x, all y, pxy is, right? So that means what? For some x, at least for one or more x, and for that x all y, this is true, right? That means we have at least one or more x, but for that, for all y. For that x value, for all y, this must be true. Now let's read it. There exists some y, not some y. There exists some x, yes, some x, such that pxy is false for every x. No, pxy must be true for all y. Pxy is true for every y. Yes, this is correct. Pxy is true for every x. No, Pxy must be true for every y. Here both three are referring to x. What about this? For every y, there exists some x such that Pxy is, but that is reverse way. Remember, exists x, all y is not same as saying all y exists x. Those are two different things. This means for at least one x, for that x, every y. This means for all y, there's at least one x. Those are two different things. So therefore, I will not go for this. Right? I will not go for this. So I'll go for C. I'll go for C. Yes, answer is C. So yeah, that you need to remember. Not remember, you need to understand. Right? Logic. Quantifiers. So this means for at least one x, and for that takes all y. This means for all y values, there's at least one x that is true. Okay, two different things.
So then can't we read other bit?
What do you mean by read other way? No, you must read left to right. This is a statement.
Okay.
This is like a sentence. Right. 9. Number of proper subset for set PQRS. So remember, number of proper subsets is 2 to the power, right? Is it we had a formula for that, right? Power sets. Like what is that formula? So for example, if we have 2 to the power n, right? Yes, 2 to the power n. But that is for power set. Remember, that is for power set, right? Power set include the set itself also, right? Set itself also is a subset, but this is proper subset. So therefore, you need to subtract 1. Subtract 1. So therefore, here we have n is 4. 1, 2, 3, 4. 2 to the power 4. But that is the number of subsets, possible subsets. But this is number of possible proper subsets. So then you need to subtract 1 because your subsets include itself. So therefore 2 to the power 4 is 2, 4, 8, 16. 16 minus 1, I'll go for 15. Right? D. Oh, examiner has taken B also. Why is that? That can't be right. How can we say that two answers are correct? Number of proper subsets. So maybe examiner is generous. Okay. Otherwise, my answer is always D. Okay. Shall we ask from ChatGPT? Because you need to subtract that one. Yeah, 15. So answer must be 15. Maybe examiner is little bit generous. 10. Which of the following proposition are logically equivalent to P implies Q? So what is the meaning of P implies Q? This is equivalent to, can someone tell me what is the equivalent statement for this?
D.
Not Q.
No, there's an equivalent statement for P implies Q using other things.
P implies
A. A.
QOR.
Not P. Not P O Q.
Not P or Q, right? Not P or Q. That means either Q has happened or P has not happened, right? So that is the equivalent statement, right? Either Q has happened or P has not happened. Why? Whenever P happens, Q happens. Whenever P happens, Q happens. So therefore, either Q must have happened or P has not happened. Those are the possibilities. Those are the two possibilities. Okay, those are the two possibilities, but you get from here because whenever P happens, Q happens. So therefore, either P has not happens. Okay. Sorry, not that, right? Not P or Q. No, I think that is not the equivalent statement. Ah, yes, correct, right? Correct. Either P has not happened or what is that equivalent statement? Shall you open the note? I can't remember. Okay, let me open the note. Logic.
Q has not happened and P has not happened.
Can you repeat that? Q has
P
not.
has not happened and P has not happened.
Can you repeat again?
Q has not happened and P has not happened.
Not Q and not P. No, I don't think so.
Implies.
That is contradiction.
No, that is not what I'm looking for. There's equivalent statement. Let me open the note. Let me open the note. So there's equivalent statement. This one. Not X or Y. Okay. Not X or Y. Let's get back to that. Right, this one is correct, right? Not X or Y. This one is correct. Yeah, this one is correct. So your previous statement. Not X or Y. Either Q has happened or P has not happened. So if P has not happened, Q doesn't happen, right? Q doesn't happen. Right, now let's see whether we can argue because what we need is logical equivalency. This is not correct, right? Because the converse is not going to work. P implies Q doesn't always means Q implies P. Right. So this one is, do we have this not P or Q? Yeah, not P or Q is correct. This is by definition. Not P or Q. So this says P or not Q. P or not Q. I don't think we can get something like that. Okay. P or not Q. Either P has happened or Q has not happened. can we take something like that? P has happened. So if P has happened, definitely Q happened also. Or Q has not happened. But that also makes bit of sense, right? Bit of sense. It's a difficult question. So can we say that not P implies not Q? No. Just because P has not happened, we can't say Q has not happened, because Q can happen for many other reasons also. Because this is not if and only, right? So Q can happen without P happening. So therefore, just because P hasn't happened doesn't mean Q hasn't happened. So therefore, this is definitely not no for me, right? So if Q has not happened, can we say P has not happened? Q has not happened. Right? Q has not happened. So whenever P happens, Q happens. Right? So if Q has not happens, yes, P has not happened, right? Because whenever P happens, Q happens. Right? Whenever P happens, Q happens. So if Q has not happened, definitely P has not happened. Right? Q has not happened. Because whenever P happens, Q happens. So this is correct, right? Is correct, right? Is it correct? Whenever P happens,
Yes, sir.
whenever P happens, Q happens. Then if Q has not happens, P must not have happened. Right? For me, that also look okay. This is not correct. This is not correct. P implies Q doesn't mean Q implies P. Okay.
Excuse me, sir.
What about E?
Excuse me.
Yes.
So can't we draw truth table and see, sir?
Yeah, that is also possible. But then you must have the exact truth table, right? Yeah, that is another possibility. But if you then you need to get the exact truth table, okay? For each combination, you must have the same output. For this output for this must be the output for this. Okay. Right. I try to get a shortcut first. Right. What about this PO not Q?
E is not correct.
Which one?
E.
PO not Q. P happens. Whenever P happens, obviously Q happens. Whenever P happens, Q happens. PO not Q. I don't think we can get something like that, right? Anyway, if it is wrong, of course, it doesn't make sense. Otherwise, it must make sense. But I also feel like there's no sense about this, right? So I'll go for A and D, but your best chance is draw the truth table, okay? Right, I'll go for A and D with my gut feeling. But if it is not correct, we will draw the truth table and double check also, okay? Yes, A and D. A and D. Okay. But don't rely on your gut feelings. Okay. Don't rely on gut feelings. This is if you have no other option and you're running out of time. Right now, let's prepare a truth table. I'm not going to do it for all the answers because it's time consuming, but I will just show it for one answer only. Okay. For example, I will do it for A because anyway, this is correct answer also, right? Right. So what is the truth table for P implies Q? This is P, this is Q. True, 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 false, false, true, false, false. Then P implies Q is, by definition or by logical uh, definition, true, true is true, true, false is false. This is true, this is true. Now I need not Q and not P. Not Q. That is false, true, false, true. That is not Q. Then I need not P. Uh, false, true become false, false become true, false become true. Then I need not Q implies not P this way. False, false, false means true. True, false means false. False means true. True, true means true. True, false, true, true. Here also true, false, true, true. These two are equivalent. Can see? This is equivalent to this because I got true, false, true, 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 false, true, true. So likewise, you need to check for each. But that is time consuming, but that always 100%, right? You don't rely on your gut feelings. Okay. So therefore, when you have this kind of a question, again, take it last because maybe you have enough time. Maybe you have enough time. Usually you should have enough time. Okay. Because there are simple questions also, like probability questions and so on. Right. So you need to do that for all 5. But if you know that some of these, like by definition, P implies Q is not P or Q, then you don't need to waste your time. Right. 11th question. Let A is 2, 3, 4, B is real numbers, which are, now these are easy questions, right? Which of the following must be true? So see whether you can solve this, right? These are typical questions, right? So x squared, when you multiply, you must get, so when you add, you must get -7. And when you multiply, you must get 12. Do we have such numbers? Multiply 12, simplify -7. Yeah, -4 and -3. -4 and -3. So therefore, this is x squared minus 4x minus 3x plus 12 equals 0. When you take x out, x minus 4 minus 3 out, x minus 4 equals 0. X minus 4 into x minus 3 is 0. So that means x equal 3 or x equal 4. Or, right, so the solution now, our B set is 3, 4. Right, B set is 3, 4 because those are the solutions, real solution for this. Real solution for this, okay? Right, so now we can answer. A is B? No. A intersection B is A. A intersection B is not A. Intersection B is B. Okay. A is a subset of B? No. A union B is B? No. A union B is A. Sorry, 3, yeah, because B is a subset, yeah. So A union B is not B. A union B is A. Yes, A union B is A. So the answers are, answer is only C. Answer is only C. So answer is only C. Right. What is the negation of this? Now, this is a tricky one. Right. Negation of this. Right. What is the negation of P implies Q? Negation. Is it not P implies not Q? But negation is not always correct, right? But they need this negation, I think. P implies Q. We discussed that. I can't remember exact thing. Let me open the note. Right. Inverse, converse. So what is mean by negate? We discussed about inverse, converse, but what is negate of this? I think negate is positive. So contrapositive means negative, right? So I hope negation means contrapositive because contrapositive, right? But remember, contrapositive is not correct, right? What is correct is, yeah, sorry. Yeah, contrapositive is correct, right? If X implies Y, not Y, right? Contrapositive is other way, right? Maybe contrapositive is not negation, right? It's okay. So I'm not very sure which one is a negation now, okay? Shall we ask ChatGPT what is negation because I have no clue. What is the negation of, then of course we can find, I can't remember what is negation. Why? You just negate like this. Not X implies Y. Right? Not X implies Y. Right. So now let's do it like that. Right? So negation means not X implies Y. Right? Not X implies Y. And we know that X implies Y is not X or Y, right? Not X or Y. So applying De Morgan rule, this is not an, remember De Morgan rule means this we need to negate this, not X, which is X, and not of Y. So these are equivalent statements. This one is equivalent statement. This one is equivalent statement. This one is equivalent statement. Now shall we look at the answers there? You don't have the not X implies Y anywhere. This is now Q implies R. Okay, Q implies R. So therefore, let's write it for this statement. So this means not P implies POR. Okay. POR. So that means not X or Y, not POR. Right? Not POR. Okay. Not PO, not POR, but we have negation also. Negation. So this is not POR, right? Correct, right? Not X or Y, correct. Now, if I apply the De Morgan rule, not of not P is P and not POR. So these are all equivalent statements. Okay. Now let's see whether we have any of these. Right. P. I can apply De Morgan rule again here also. Then P and not P and not R. That is another option. Not P and not R. Do we have that at least? No, right? P and not Q, and sorry, this is Q, right? Sorry, I made a mistake. This is not P, this is Q. Q. Do we have this P and not Q and not R? Yes, we have this. This is correct. No, this is not P, right? Sorry. This is also not correct. This is also not correct. B, P and not Q and not R. Yes, B is correct. P and not Q and not R, correct. What about this? Is it our intermediate results? No, right? This says not Q or R implies not P. I think, no, that is a contrast positive, right? Not Q or R implies not P, but contrapositive is, but what they ask is negation, right? What they ask is negation. So therefore, this is not the negation. This is contrapositive. So therefore, we'll go for B. Right? We'll go for B. Yeah, answer is B. So it's a tricky one. So remember, negation means negation of X implies Y is not X implies Y. So then you need to convert this into our this format because then only we can apply rules, right? Because there are no rules for this. That is why we always convert this into this, because the moment you convert into this, we can apply other rules, because other rules are always related to that. So then any of these are positive answer, correct answers, but only we had this answer, final answer. Okay. Right. So tricky question. Okay. So you can see lastly logic questions
Excuse
are.
me, sir.
Yes. Yes.
If they ask for a equivalent statement for this rather than the negation, can we take C then?
Can we take what? B.
If no, sir, if they ask for a equivalent statement rather than negation,
Okay.
can we take C then?
C. C is this one.
They ask the question like,
Yeah. So
it's a
then,
contrapositive
yeah. So then equivalent statement means X implies Y means not X or Y. So that is not P or Q O R. Okay. So is it equivalent to this one? Not QOR is this is not QOR. So then you need to convert this also into this format and see whether those two are equivalent. For example, if you want to check whether this is equivalent to this, then convert this also this statement, right? Because X implies Y means not X or Y. So that means not of not P, not of not P, or right, that is not X, then Y. Y is sorry, not X means this one, right? Sorry. So not X means this one. So not and not get cancelled. QOR, right? Not X or Y, right? Not X or Y. The Y is not P, not P. So then yes, those two are equivalent. You can see not P or QOR, QOR. Yes, these two are equivalent. So if they ask for the equivalent statement, this is equivalent to this. Yes, this is equivalent to this. Okay. Because it's a contrapositive. Anyway, contrapositive is equivalent, right? So actually, this is the contrapositive, right? So you need to change the left, right, and then take the negation. Remember here we mentioned contrapositive is correct. If X implies Y, not Y implies X is correct. Not Y implies X is correct. So contrapositive is correct, right? But converse inverse are not correct. Negation is also not equivalent, right? Negation is maybe I should add the negation also to this slide because negation is not here, right? Negation is not here, so I should add negation also because contrapositive is equivalent. Converse inverse are not equivalent. Negation is also not equivalent, but unfortunately I have not added negation to this note. Maybe I should add it, right? I will add it and upload it. So that at least other semester students get that benefit. Okay, of course. Now you also know that negation is not equivalent, right? Right. Right. Next question. Let P, Q, and R be three propositions with truth value true, false, and false, respectively. Which of the following propositions are true? Right. So that is not a difficult question because they have given the truth values. Right. Right. First one. Again, it will take bit of time, obviously, bit of time. So in the exams, I will do this last, but this is highly doable question because it's very easy. Just you need to consider only one scenario now, right? Because they say uh, P is true, P is true. So this is something like true if and only if Q and R false, false or false. So false or false is false. Right? So that is true if and only if false, right? So what is the if and only if truth table? A, B, A if and only if B, true, 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 false, false, true, false, false. True, true is true, true, false is false, true, false is false, false, false is true. This is true, false. True, false is false. So the question is, which of the following proposition is true? But true, false is false. So therefore, this is not true. This is false. Right. What about this? P and Q. P and Q. P, Q. True and false is false. And not R. R is false, right? So R is false means not R is true. false and true is false. So therefore, this is false. Right? This is false. This is not the answer. What about this? Q. Q is false. If and only if P and R, that is true and false. P and R is true and false. True and false is false. False if and only false is true. So this is true. This is an answer. So this P is true. P is true. True implies Q, which is false. And not R is true. True implies false is false. False and true is false. So this is not answer. This is P. P is true implies Q. Q is false. Implies R, which is false. True implies false is false. False implies false is true. Right? False implies false is true. When first one is false, output is true. False implies false is true. So therefore, this is an answer. Because what we need is true. So the answers are C and E. C and E. Okay.
Sir, if it is false implies true, it is false or true?
The truth table for implication is this. This is if and only if. A, B, A implies B. True is obviously true because you say A implies B. A has happened and B has happened. True false is false because you say A implies B, but A has happened, but B has not happened. So that means your logic is false. And when A is false, always this is true because your statement is not challenged. Because what you're talking is when A happens, B happens. If A has not happened, you don't care about that. You are not accountable for that. Because what you are saying is when A, then B. So A has not happened means your statement is still true. Right? Or your statement is not challenged. Okay.
Okay.
Right. Is it clear, right? So, because first of all, you must understand why this truth table is there. Because when you say if X then Y, if X has not happened, you can't challenge my statement. You can't challenge my statement. Right. Next question. Right. This should be easy question. Usually set question doesn't take much time. Set A equal ABC and A minus B is 5. Then set B is A minus B. That means belong to A, but not belong to B. That is here. Belong to A, but not belong to B. It is 5. So that means A must be inside B. Right? That is why there's nothing belong to A, but not belong to B. So that means all the elements in A must be in B. Okay? Right. So that means basically I can redraw this something like this. If this is B, this is my A. All the elements in A are B. And also there's a possibility that A equal B. That type we can't eliminate because when A equal B also A minus B is 5. Okay. And when A is inside also A minus B is 5 because when you remove all the elements of B from A, you have nothing. Okay. Right. So therefore, set B can be. So we have A, which is ABC. So set B can be ABC or anything ABC and anything else. But everything in A must be in B. Right? Everything in A must be in B. That means definitely your answer must have A, B, C elements. A, B, C elements. Here C is not there. This is not answer. C is not there. Not answer. C is not there. Not answer. C is A, B, C all are not there. So here A, B, C is there. Yes. Possible B. and anything else can be there because B can have additional things. So this is a possibility. This is a possibility. So answer is D. D. Okay. Right. 15. If A is 1, 2, 3, B is 2, 4, 5, C is 2, 5, then A minus B cross B minus C. These are easy. I don't know. It depends on you. I recommend you just is if actually if I was you, right, I will start with set questions because usually set questions don't take much time because you don't need to draw truth tables and such kind of things. Okay, so drawing truth table is the time consuming one. Okay, even probability questions won't take much time. Right, I will keep the logic questions to the last most of the time. Okay, but because I'm just discussing the questions with you guys, I'm doing this way. Otherwise, I will always start with sets. And also indices logarithm questions, whether you can do it or not, it is a different thing, but usually it doesn't take much time. Right? Right. A, B, C. This is equivalent to. Right. So you can find A minus B from A values. We get rid of B values. Right. If it is in B, you need to get rid of. Right. 2 is in B. Others are not in B. So therefore, your A minus B is 1, comma 3. 1, comma 3. Then what about B minus C? It must be in B, but if it is in C, you need to get rid of it. So 2, you need to get rid of it, but others are okay. So that means 4, comma 5. It is in B, but not in C. 2 is there, therefore I took.
So 5 is inside C.
5 is inside B minus, sorry. I need to look at the B and C, right? Not B and A. Sorry. So I need to now look at the B and C. Right, B minus C. So it must be in B, but not in C. So that means 2, we need to take it out. 5, we need to take it out. Right. So then we have only 4. Yes. I just look at the wrong set. Right. Now we need the Cartesian product. So you need to connect. It's very easy. 1 with 4, you get ordered pairs. And 3 with 4. 1, 4, 3, 4. And it must be a set. So this is not correct answer anyway. Anyway, these are wrong ordered pairs. It must be a set. And each element must be ordered pairs. Pay attention to that. So these are anyway wrong because this is not a set. This is not ordered pairs, right? But the correct ordered pair is 1, 4, 3, 4. And this order matters, but this order doesn't matter. You can say 3, comma 4, then 1, comma 4. But this order matters. You can't say 3, comma 4 as 4, comma 3. Okay? But these two can be swapped. So the answer is A. 16. Let A and B be two sets. Which of the following statements these are false? False, not true. A minus B. Okay, shall we draw it? Because that's easier. So this is A, this is B. A minus B means belong to A but not belong to B. This. What about this? A intersection B complement is everything other than this. Everything other than this include these things also. So therefore this is not correct. This is not true. Okay. Right. A minus B is this part. From A, you subtract A intersection B. From A, you subtract A intersection B. So then you get this. So this is correct. This is true. So A minus B, this one. From A, you subtract B complement. So when you subtract B complement from A, this is your A. Let's do it. Anyway, it looks like this is false, but I just want to draw it and show. Right. So this is my A. From this, I want to get rid of B complement. Right? I want to get rid of B complement. So when you get rid of B complement, these things are also removed, but these things are shaded because B complement include this. So red part must be removed from blue part. So therefore, this is not answer. So what about this? A union B is this part. From there, you get rid of B. That is correct. So when you get rid of B from A union B, you get this blue line. This is correct. A minus B is not B minus A because B minus A is this. So the answers are B and D. Right? B and D. Sorry, B and D and E. Or sorry, B and what is that? False, right? False answers. So then why do I get only two answers? A is correct. That is a real mess, right?
The B is correct. It's not wrong.
B. Which one you are
Yes.
referring to?
16B.
B is correct.
Yes.
Yes, B is correct. D is correct. Right?
Sir,
So
A is correct, no?
A is correct. A minus B belong to A and not B. Yes, A is correct, right? A is correct. Belong to A and not belong to B. Correct. So then the answer must be C and E. Right, correct. C and E, correct. Right. So remember, this is false, right? False, not true. You are supposed to mark only false answers. Yeah, C and E. C and E. Sorry for that. Okay. Right. Let A, then number of subsets of A containing exactly two elements. This is more selection or combination question, right? Because not permutation, because when you rearrange, it is not a new set, right? New set. Right. So we have 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 elements. So out of 10 elements, how many ways, right? Out of 10 elements, how many ways we can take number of subsets of A containing exactly two elements? How many ways we can take two elements? R equal to, right? That means AB is a possible subset. Right? AC is a possible subset. BC is a possible subset. AH, right? And so on. And these are distinct elements. Distinct elements. So that is 10C2, right? 10C2. How many ways we can take 2 from 10? That is factorial 10, factorial n divided by factorial r divided by factorial n minus r, right? So 10 into 9 remains because other things get cancelled out. 10 into 9. So here we have 2 because 8 factorial get cancelled out for this. And this is 5. 45, right? 45 ways. So it looks like sets, but actually it's a combination. B. Let X and Y be two finite sets. Two finite sets. If the total number of subsets of X is 112, more than the total number of subsets of Y, the number of elements in X is. Okay, so this is a real tough question. Right. I think this paper is one of the toughest papers I have seen in your BIT semester 1 papers. Right. So usually, because we did the previous paper also, right? 2023 paper. Sorry, not previous paper. The last paper, which was not this tough. Okay, so this is tougher. Right. Let X and Y be two finite sets. If the total number of subsets of X is 112, more than the total number of subsets of Y. Right. So So that means X must have more elements than Y, because total number of subsets of X is 112 more than the total number of subsets of Y. Okay, so total number of subsets of X is number of elements in X is, right? Yes. So if we have n elements in X and Y elements in M, okay, and assume n is greater than m, because total number of subsets in X is 112 more than total number of subsets in Y. Okay. So then we have the total number of subsets of X. X is then 2 to the power n. Right. And when you subtract 2 to the power y, sorry, 2 to the power m, because that is the total number of subsets in y, it must be 112. 112. Okay. So that means now we need to find number of elements in X. That means we need to find n. We need to find n. So this is not a question that we can just, because there are two variables, but maybe we can guess it. Guess it. If we can guess it, that is fine, because these are 2 to the powers. Okay, 2 to the powers. And also we have possible answers also. Okay, so that means we can use one of the n value and see whether we can get a possible m value. If we can get a possible m value, that is a possible value. Okay. Right. So it can't be 5, right? Because 2 to the power 5 is 2, 4, 8, 16, 32. When you subtract something, you don't get 112. So therefore, I will not take A, because 2 to the power 5 itself is also lesser than 112. So then what about 7? 2 to the power 7? 2, 2, 2, 2, 2, 2, 2, 2. 4, 8, 16, 32, 64, 128. 128. Can I subtract by something of 2 to the power to make it 112? Right. So basically you need to check whether if this is X, right, my X must be 2 to the power. So then my X is 128 minus 112. 8 minus 2 is 6. 2 minus 1 is 6. Sorry, 1. Yes, 16 is 2 to the power 4, right? So therefore, if this is 7, other thing can be 4. So then this satisfies. So therefore, this is a possible answer for me. Because if this is 7, other one can have 4 elements. So then this is satisfied. Okay. So then you need to use 9. Okay. So that is 2 to the power 9 minus, say that X must be 112. 2 to the power 9 means, now already we have 128. 128 into 2, 256, 512. So then X must be 512 minus 112, which is 400. So 400 is not a 2 to the power. So therefore 9 can't be answered. So likewise, you need to check for 11 and 12. Right? Either check කරන්න. මොකද හරියන්නේද තියෙන්නේ. Right? හරියන්නේද තියෙන්නේ. Because 2 to the power 11 means 1024 into 2. 1024 into 2 is 2048. 2048 minus 112 බලන්න දෙකේ බලයක්ද කියලා. Right? දැනට මට උත්තරයක් ඇවිල්ලා තියෙනවා. D. Okay? Yes, only answer is D. Right? Only answer is D. ඒ කියන්නේ අර දෙකේ බල වෙන්න බෑ. Right? So this paper is not just checking sort of your theory part. It's basically check whether you have a good logical thinking. Actually, it's a very good paper. Right? Very, very good paper. Maybe getting A plus is difficult, but anyway, it's a very good paper. Okay. Right, 19. So let's move on to question number 19. Let A be a set with n is greater than or equal to 2 elements and B be a set with 2 elements. How many onto or surjective functions are there from A to B? Right, so that is relation question, but it looks like it's more like again combination or permutation question. Okay, right. So let A be a set with n greater than or equal to 2. Right, so we have set A and B be a set with 2 elements. B has only 2 elements, right? Say X, Y. Let A be a set with n which has greater than 2, right? So it's like A1, A2, A3 and so on, but definitely greater than 2. How many onto or surjective? Remember, onto means there are no orphan values in the range side. We have discussed those, right? There are no orphan values in the range side. How many onto functions are there from A to B? A to B. So that means all these values, and it must be functions. So function means every value must be mapped. There can't be orphan values in the domain side. So that is the part of definition of function. So function means two conditions. One is no orphan values in the domain side. Second, it must be one to one, no many to one. It can't be one to many. One to many. Okay. So this is right. So we have n elements here. It can't be one to many also. Sorry, it can't be one. It can't be one to many. Okay, it can't be one to many. So let's see whether we can see a pattern because I don't see any other way of doing this. Let's assume we have only 3 elements because it must be greater than or equal to 2. So then what are the possibilities? If n is 3, okay. So we have only 2 here and it must be a function also. That means no open values. So maybe this map to this. And this can't then map to anything, then it is not a function. So then this map to this. Right? So then this one can map because this one must map, otherwise it is not a function. Right? So then it has two possibilities, that is map to X or map to Y. Right? Because these two must be mapped to this. And there's another possibility that this can map to this. Right? But if this is mapped to this, then this must be mapped to this because everything must be used because this is onto. Right. So then if it is 2 elements, if n is 2, how many possibilities? This map to this map to this, and this map to this, or this map to this map to this map to this. So there is 1, 1, 2. Right. So then this can map to this and this can map to this also. So then 2 into 2 is 4. So then I get 4 possibilities. 4 possibilities because these two can be swapped and this can be mapped to this, so this 4 possibilities. Okay. If it is 4, what will happen? I just want to see whether we can see a pattern. Okay. Pattern. So let's see if I have 4. Anyway, don't do this kind of question upfront, or maybe you can skip altogether. Right. I'm just doing this because I'm not in the exam, right? So this is N1, N2, N3, N4, and this one has only 2. So maybe this map to this map to this. That is one possibility. Of course, this one has 2 possibilities. This one always has 2 possibilities. Right? This one always has 2 possibilities. Now, how many possibilities? That means 3 elements map to 2 elements, right? This and this. And then this one can map to this, or this one can map to this. This one can map to this. That is one possibility. Then this one can map to this. That is another possibility. So then 1, 1, 2. 1, 2. So that is two possibilities, but here they can swap. That is again 2 into this guy has 2 into this guy has 2 into the 2 to the power 2. Sorry, this one has 2 to the power 1 possibility. Because this can map to this, or this can map to this. Okay. But this one always need to map to this one and this. The rest of the stuff is because anyway 2 elements must be mapped to these two. Okay. But again, there are possibilities like this map to this map to. I don't think that this is an easy question for me. Okay, because just like this, there can be these two map to this, these two map to this, and so on. Okay, I'll just keep that for the time being. Right, there are so many possibilities for me now. Okay, so I'll just keep that for the time being. Okay, it's too much possibilities coming to my mind. Right, so we'll move on with other questions first. Okay, right, 20. In a group of 72 students, 47 have background in physics, 59 have background in mathematics, and 42 have background in both subjects. How many students do not have background in both physics and mathematics? So that is the easy question. You can see there are easy questions also, right? So we have physics, mathematics, yeah, only two. Say this is physics, this is mathematics. In a group of 47 students, your universal set must have 72. And 72 students. 47 have background in physics. 47 has background in physics. 59 have background in mathematics. 59 belong to this circle. 42 have background in both. 42 here. So if 42 here, this must be 5 because altogether 47. If 42 here, this must be 59 minus 42. 9 minus 2 is 7. 5 minus 4 is 1. 70. How many students do not have background in both physics and mathematics? So now you can count these three and subtract from 72. Right. So this is 47 or this is 59. 59 plus 4 is 60. 59 plus 5 is 64. So then 72 minus 64 is this. 72 minus 64. 8. Right. 8 students. So 8 students they don't have background in both physics and mathematics. Okay. So I hope here the word both means, right? But this says both physics and mathematics. Its wordings are a little bit confusing. I hope what the examiner means is both physics or mathematics, because both physics and mathematics is this. Right? So therefore, one possible answer is 8. Other possible answer is both physics and mathematics. If you take it in very literal meaning, that is 72 minus 42. But luckily 30 is not in the answers also. Right? So therefore, anyway, I'll go for A. Okay, so that means I hope both physics and mathematics means neither of those. Okay, I'll go for A. Yes, A. Okay, right, 21. Let f and g be the functions from the set of integers to the integers defined by fx 2x plus 3 gx. Right, so this is another easy question. So these are the sort of a textbook questions, right? Right, so let's draw x and f and g. So f, that is 2x plus 3. 2x plus 3. Gx, f0g means what? F0g means f of gx. F of gx. F0g means f of gx. Okay. F of gx means, so you need to first do gx and then do fx. Okay. So therefore, f of g of 2 I don't need diagram now. Right. G of 2 is this. G of 2 is 3 into 2 is 6. 6 plus 2 is 8. So that is f of 8. F of 8 is 8 into 2 is 16. 16 plus 3, 90. 90. Answer is E. Right. Question 9, they have mentioned something about, anyway, this answer should be correct. 21 answer must be E. Yes, answer is C. There's a note on question 9. What is that note? I missed that. Question 9. All right, so that they have given, I told you that the exact answer is, I think, 15. So, right, yeah, that is fair. So, examiner is just giving bit of generosity for the students, okay? Right. And there was another chat explaining, can you explain 18 question again? 18 question. Right, so the 18 question means, so let x and I will explain it again. X and y be two finite sets. If the total number of subsets, remember, if you have n number of elements in x and m number of elements in y, total number of subsets for x is 2 to the power n. Total number of subsets for y is 2 to the power m. And according to this, the difference is 112. So therefore, I wrote it as 2 to the power n minus 2 to the power m is 112. So that is, I just take it from this statement. Okay. So then they ask, what is the possible value of n, number of elements in x? So because we have two variables and one equations, we need to do a bit of trial and error. Trial and error. Because you can't solve equation when we have one equation and two variables. But when we have the answers, we can do it. So therefore, I just took the smallest one as my n, and I check whether is it possible, because 2 to the power 5 is 32. Then I subtract 32 from 112 minus 32 and check whether is it a 2 to the power, because this must be a 2, m must be a 2 to the power. And it was not a 2 to the power, so therefore I rejected that. So then I took n as 7. So 2 to the power 7 I know. Right. From that, I subtract 112 and check whether is it a 2 to the power. And I found that yes, it is 2 to the power 7. So therefore, I took it. So then I ask you to do the same for 12 and 11 also, because 2 to the power 11 is 1024 into 2, 2048. And I ask you to check whether is it a 2 to the power when you subtract 112. If it is so, that is also answer. And then check 12. Right. So when we have two variables, but when we have clues, we may check whether that is possible answer. Okay. We are not solving the problem. We check whether do we have any possible answers satisfying our problem. Okay. Because two variables are unknown. Still we can find it. Because help is there. Okay. Right. Right. Next question. 22. If 2 plus 2 is 4, then 2 plus 3 is 5. Conditional statement is true, right? So remember 2 plus 2 is 4 is true, right? So that is, if it says like if x, then y, but this is true. It's something like if true, or true implies, right? True implies 2 plus 3 is 5 is true, right? True implies true is true for me. So this is true implies 2 plus 3 is 6 is false, right? It's like true implies false. True implies false is false for me. This is 2 plus 2 is 5. But 2 plus 2 is 5 is false for me. 2 plus 3 is 5 is true. False implies true. Okay. But according to the truth table, this must be true. But now, anyway, let's first go through the truth table. 2 plus 2 is 5. That is false. 2 plus 3 is 4 is false. Right. According to truth table, this is true. If 100 is greater than 200, that is false. Implies 200 is less than 300, that is true. False implies true is true for me. Okay, if I go by the truth table, my answers are A, C, D, E. But do we need to think about the reality? If this is true, this is true. But definitely A is answer. Definitely A is answer. If 2 plus 2 is 4, 2 plus 3 is 6. That is not an answer because true and false. Yeah, this is definitely not an answer for me, but these are the debatable ones because these are false. This is false, this is false, this is false. When this is false, this is true, right? But according to the truth table, false implies false or true or whatever is true. If you take 2 plus 2 as 5, anyway, that's a tough one. That's a tough one. Should I go for only A or should I go for A, C, D, and E? Okay, that is the question now. Right. So if I go by the truth table, I'll go for A, C, D, and E because this is anyway false. So when this is false, I can't do anything for this, right? Yeah, if you go by the truth table, I need to answer as A, C, D, and E because I don't get any other possible logic for this because that is what we have learned, right? Truth table. I'll go for A, C, D, and E. Anyway, it's a debatable one for me. I don't know whether you have a better explanation for that. Yeah, so examiner has taken A, C, D, and E, but I just wondering how do I explain this to you guys. But definitely, yes, I can explain this and this. But if 2 plus 2 is 5, obviously we know that it is false. Then 2 plus 3 is 5 is so true. According to the truth table, false implies true is true. But how can I explain it in practical way? If 2 plus 2 is 5, if this happens, but this has not happened, right? Anyway, according to the truth table, yes, we get our answer is correct, okay? But how can I explain? Shall we ask ChatGPT to explain this? I don't know how whether ChatGPT explain it, right? Anyway, our answer is correct, but I just wonder whether we can get a better explanation for that. Right. So true. Since P is true and Q is false, correct. I think ChatGPT just go by the truth table. Right. If the premise is false, the whole condition is true. Yeah. So ChatGPT also just go by the truth table, right? No bit. That is the only explanation I also can give, right? So same explanation, just go by the truth table, right? But yeah.
So you can ask a real world analogy.
From ChatGPT.
Yes.
Yeah, maybe real world analogy. Maybe then ChatGPT will explain what is a real world analogy for false implies true. Okay. Because the condition is not satisfied, we don't care, we don't account for the second one, right? Yeah, if it rains, then I will take umbrella. They just talk about negations and so on. Okay. That is not. Maybe I can ask, of course, that is the same as asking if X implies Y, right? When X implies Y, anyway, that is that if your X is not true, we don't care, we can't account for that. I think that should be the explanation. Why is it when X equal F and Y equal true is true? Anyway, that, and at the end of the day, when X is false, our condition is not challenged. Okay. Right. So again, it's just now imagine it doesn't rain. That is X is false. No promise is, you can see no promise is broken. Right. So our thing is not challenged. Okay. Uh, whether you take the umbrella or not. Okay. So because the original statement only make a promise when X is true. If X is false, the implication doesn't say anything at all. So it is not violated. Right. So that's the only explanation, right? That's the only explanation, right? Because this is not true thing. So therefore, don't check whether this is true or false, because this is not something not happen and not true. Right. Anyway, it's confusing questions. Okay. Right. What about the next one? What is the negation of the statement? No one wants to buy my computer. And that is interesting one, right? So this very interesting paper. No one wants to buy my computer. That means not a PX. Right? No one want not to, right? Not all, sorry, no one wants to, sorry, no one wants to buy my computer means not exist, right? Not exist XPX, right? Not exist PX. Exist in a PXI, not exist XPX. Right? No one wants to say PX is buy my computer. So no, none exists which is satisfying PX. Right? So then what is the negation? If no one want to buy my computer is my statement, so then negation is not exist, right? Uh, not exist PX. Negation is it someone want to buy my computer, right? No one want to buy my computer. Negation must be someone want to buy my computer, right? Yeah, not exist means exist X. Yeah, I'll go for this. Someone want to buy my computer because that is the best I can think of. Right? No one want to buy my computer. No, there are some people who want to buy my computer. Right? So it doesn't mean that no one want to buy my computer's negation is all want to buy my computer, right? No. Right? Everyone want to buy my computer. No. Everyone doesn't want to buy my computer. So that means again no one want to buy my computer. None of these. So I'll go for B anyway. So these are a little bit fuzzy logic. Okay. My gut feeling says it should be B. Okay. Yeah, it is B. It is B. Okay. Right. What about the next one? Which of the following statement is are true if the domain consists of all integers? Right, all integers. all n plus 1 is greater than n. For all integers, when you add 1, it must be bigger than the original 1, correct? Right? I'll say yes. For any integer, when you add 1, that integer is bigger than the original 1. Right? All. First, I will look at the easier one. X is 10, twice of n is 3 times n. Remember, 0 is integer. So when it is 0, 2 times 0 is 3 times 0. This is correct. I just need to find one answer. And this is again for 0, 0 is equal to minus 0. Right? So what about this? All n, 3n is less than or equal to 4n. No, I can find a contradiction. For example, when n is 1, 3 is, sorry, this is less than, right? Yeah, if you take something like in general, yes. That means for positive numbers, this is correct. 0, this is correct because equal mark is there. Right? For all positive numbers, this is correct. 0 also, this is correct because equal mark is there. Then I want to check for the negative numbers. Say 3 times, say minus 2, is it less than or equal to 4 times minus 2? I just took minus 2 as example. 3 times minus 2 is minus 6. Is it less than or equal to minus 8? No, minus 6 is not less than or equal to minus 8. Minus 6 is bigger because minus 6 is in the right hand side of minus 8. So therefore, if for negative integers, this doesn't work. This doesn't work. Okay. So then I want to check whether this is going to work for the negative integers also, right? Yeah. Yeah. Minus 3 plus 1 is minus 2. Minus 2 is bigger than minus 3. Yeah. For negative integers, this work, but it looks like this doesn't work, right? Right. 3 into minus 2 is minus 6. Is it less than or equal to 4 into minus 2, which is minus 8? No, minus 6 is not less than. So therefore, I will not take this. For all n, this is not correct because when n is 0, 0 squared is 0, 0 is not greater than 0. I find a contradiction. Again, I can find the contradictions. So if I can find a contradiction, that's the end of the story. Okay. So therefore, I'll go for A, C, and E. Okay, A, C, and E. A, C, and E. 25. Let Q xy be predicate, x plus y is x minus y. Okay, x plus y is predicate means it can be true for some values, it can be false for some. Predicate means propositional statement containing variables, right? Depending on the x and y values, the result can be varied. If the domain for both variable consists of all integers, which of the following statement is are true? Okay, all integers. When this is 2 and 2, is it true? 2 plus 2 is 4. 2 minus 2 is 0. So 4 is not equal to 0. Therefore, this is not correct. Okay. So I first look at the easier things. Exist x, exist y, q, x, y. Yes, because it's integers. 0 plus 0 is equal to 0 minus 0. Right. Just I need one value for x, one value for y from integers. I'm just looking for because that means I got some marks. Because I can mark this as in my answer sheet and I get maybe some marks. Right. So what about this? All y, when x is 1, for all y values, this is correct. When x is 1, let's see. When x is 1, 1 plus y is it equal to 1 minus y for all y values. For example, 1 plus 5 is 6. 1 minus 5 is not 6. 1 minus 5 is minus 4. So this is not correct. Right. All x exist y. All x exist y. That means there must be at least one y. Just one y for that y for all x. That means, say for that y for all x, this must be true. Do we have such a number? That means if this is 0, right? Say this is something plus 0 is same as something minus 0. Correct. Right? Because I find 1y, x is means at least 1. Right? 0 is integer. So, but when we take y as 0, this is true for any x value, because any value when you add 0 and subtract 0, you get the same value. This is correct. I'm just trying to find out either contradiction if they talk about all, or if x is, I try to find at least one possibility. Now this is all x, all y. This is, I don't think this happen at all, because this is a very unlikely situation. All x, all y. ඒක හරියට පන්තියක 100ක් ඉන්නවා. හැමෝම හැමෝටම ආසයි. හැමෝම හැමෝටම කැමති. විරුද්ධ නැහැ. තරහක් නැහැ. එහෙම වෙන්න තියෙන chance එක අඩුයි නේද? මොකක් හරි උඩ පඩයක් තියෙනවා. හරි මොකක් හරි දෙන්නෙක් අතර තරහක් තියෙනවා. හරි. හැබැයි එහෙමයි කියලා මේක නොගෙනින්න එපා. හරි. හැබැයි මේක තමයි very unlikely scenario. Right. What is the contradiction of program? For example, 5 plus 2 is 7, 5 minus 2 is 3. Not correct. On contradiction here. Right. We have got a contradiction. Right. So my answer is C and D. C and D. Yes, C and D. Let n to n be a function defined fn equal n squared plus 2. For natural numbers. Natural numbers. That means 1, 2, 3, 4, 5, 6. Okay, all positive integers. I කියලා තියෙනවා natural numbers can positive integers. 0 is not there. Negative values are not there. Right. So that means our domain is 1, 2, 3, 4, and so on. And 1 is mapped to 1 squared is 1, 1 plus 2, 3. 2 is mapped to 4 plus 2, 6. 3 is mapped to 9 plus 2, 11. Just I want to see whether there's a pattern. 4, 16 plus 2, 18, right? Something like this. Okay. Right. So answers. Injective. Yes, it is 1 to 1, right? It is 1 to 1. One value is mapped to 1. Right. I say yes. And this side also natural numbers. This side also natural number. I forgot to mention that. This is natural numbers. This is natural numbers. Right. Natural numbers means 1, 2, 3, 4, 5. But you can see that if it is natural numbers, I need to take 1 and 2 also. Right? 1 and 2 also. Because range side is natural numbers. But no value is going to map to 1. Because even 1 is going to map to 3. No value is going to map to 2. So therefore, this is not on 2. Because there are often values in the range. 1, 2 are often. 1, 2 are often. So therefore, this is not correct. It's not on 2. So if it is injective and surjective, it is bijective. But it is not surjective, so therefore it is not bijective. We discussed those, right? So both injective and surjective, no, because it is not surjective. Neither injective nor surjective is false because it is injective. Right? Answer is A. Right. Bit of logical thinking, lot of common sense. Right. Right. 27. If you have any questions, let me know. I hope you guys have attempted this, right? Not attempted this. You must, by this time, you must have attempted at least 5 years of past papers. Okay. If you are very serious to get a good day, I told you, I don't care whether you get A or B for web development, right? Software engineering, right? But I really care if you can get an A for maths. Maths. Okay. There's no doubt about it. There's no doubt about it. That is why I want you guys to do more and more maths. More and be more logical thinkers. If you are a logical thinker, you can solve problems. You can get out of problems. You can build things. You can handle complexities. Okay. Right. 27. Let A equal A, B, C, D. B equal 1, 2, 3, 4, 5. How many one-to-one functions can be defined A to B? So that is also looks like more combination question. A, B, C, D. 1, 2. This is difficult question, definitely. Right? How many one-to-one? One-to-one function. So one possibility is something like this. Okay. So then this can be mapped to, okay, let's keep that open for the time being, right? It's, so many possibilities come into my mind. So let's keep that. Okay, maybe we can look at it last. Okay. Right, 28. If A to A be an onto function, right, there is no orphan values in the range. Onto function 1, 2, 3, and it's a function also. Then which of the following statement are true? And it's an onto function, right? So it's something like this, right? That is one possibility. You can't have orphan values, right? Orphan values here because it is a no orphan values here because it's a function. No orphan values here because it's onto function. Okay. So then there's some more possibilities, right? 1, 2, 3. It can be many to one, right? Many to one. Still, it can be a function. It can be a function, right? Because this is a function, because many to one are also functions. One to many are not functions. And it is onto function because all the values are met. Okay. Right. F is 1 to 1. Right. F is 1 to 1. Now, is it necessarily 1 to 1? That is the problem. Right? Because F can be many to one also, right? Okay. No, A to A. Sorry. This is again 1, 2, 3, right? Sorry. I didn't read it properly. This is A is 1, 2, 3, A to A. So therefore, this is also A, right? This is also A. Now, this is my thing, right? So that means if it is, we have 3, here also we have 3. Okay? Here also we have 3. Right. So now again, let's double check. So can we have this kind of for possibility now? Can we have possibility of many to one? Many to one, something like this. 1 also map to 1, 2 also map to 1, 3 is mapped to 2. So if that is the case, then this is not, because this is here we have 3, because A to A. This is not possible, then why? Because then it is not on to function. So therefore, there is no possibility of many to one. The moment it becomes many to one, it is not on to. It is not on to. So therefore, yes, it can't be many to one. Right? It must be 1 to 1. Anyway, it can't be 1 to many or many to many, then it is not many function. Right? So therefore, if it is a function, it must be 1 to 1, no, many to 1. But it can't be many to 1. The moment it becomes many to 1, there's open value. That means then it is not on to. So therefore, it must be 1 to 1. Okay, it must be 1 to 1. If maybe 1 to 1, no, many to 1, no. It can't be many to 1. The moment it becomes many to 1, it becomes not on to. Right? F is bijective. Bijective means 1 to 1 and 1 to 1 and on to. Right? Surjective and injective. So already we know that it is on to. And already we know that it is 1 to 1. If it is 1 to 1 and on to, that is bijective. That is bijective. It's a very clever question, right? F may or may not be bijective. No, F is bijective according to the given restrictions. So none of the above is wrong because we already have two correct answers. Okay, when we have two correct answers, none of the above cannot be the correct. Right. So the answer must be A and C. Yes, A and C. Okay, A and C. Right. 29. Now you can see these questions. Maybe you can do it or not, but it doesn't take hell a lot of time like those logic questions. Okay. And again, I just skip some of these questions because there are so many possibilities, right? So just skip those and do it last if you have time. Let R be a relation on a set 1, 2, 3, 4. Okay. Which of the following statement is a true? This should be an easy question, right? You just draw it. Reflexive, symmetric. Okay, shall we draw it in the other way? 1, 2, 3, 4. 1, 1, 2, 2. 1, 1, 2, 2. 1, 2, 2, 1. 3, 4. 4, 1. 4, 4. Right. It is not reflexive because 3 is not 3. It is not right. It is not reflexive. It is not symmetric because there's 3 to 4 but no 4 to 3. There's 4 to 1 but no 1 to 4. Antisymmetric means whenever A to B, there must not be B to A. But you can see there's 1 to 2 and 2 to 1. So therefore, it is not antisymmetric. It violates that also. It's neither symmetric nor antisymmetric. Transitive, obviously not transitive because it is even not, you can see it goes from 3 to 4 and 4 to 1, but it doesn't go from 3 to 1. It is not, we can find violations, right? And of course, because all are wrong, I can say none of the above. You can see examine, ask question, answer sheet also sort of a logic now, puzzle, right? 29, I'll go for E. Yes, answer is C. So this is a well thought out exam paper. Well thought out exam paper. Okay. It's tough, but it's fun. Especially when you're not in the exam, okay? So, right. So when you're in the exam, yes, it's hell a lot of stress also. Let R be a relation defined on the set of integers, Z. Right, Z, integers. And XY are members of R. Here, R doesn't mean real numbers. R is a set. Okay, R is a set. Because it's for integers. Set of integers. Right. If and only if x plus y must be less than or equal to 3. Right? X plus y must be less than or equal to 3. Let's draw it a little bit bigger. Right. So these are for integers. Integers means negative whole numbers are also possible. That make it even harder. X plus y must be less than or equal to 3. That means y must be less than or equal to 3 minus x. Okay, so if it goes from x to y must be 3 minus x. From 3 you subtract x. Okay. So definitely it can't be reflexive because there's nothing called 5 is mapped to 5, right? So therefore it's not reflexive. At least I can get rid of some wrong answers. Right? Can it be symmetric? For example, when x is 5, 3 minus 5, we have ranges, right? Range of values. But anyway, it's not reflexive. Anyway, it's not reflexive, right? Because it won't map 5 into 5, 3 into 3 like this. But equal mark is, equal mark is there, but it must be less. This is inequality, okay? So this is tough question again. This is inequality, right? Not equality. Y must be less than 3 minus 6. It's something like this. If I draw this, y equal minus x is something like this. Then plus 3. Plus 3 is it's something like this. Y equal 3 minus x is something like this. Because y equal minus x is this. Because y equal x is this. And then you add 3. Up it by 3. So therefore this is 3. And y must be less than. So it's something like this area. Okay, so this is basically this inequality. Now can it be reflexive? Reflexive means 2 into 2, 3 into 3. Can we have like that? But these values can't be, right? These values can't be the answers. Right? For example, reflexive means 1, 0 into 0. Yes, 0, 0 is a possibility. 0 is less than or equal to 3. But what about 5? X is 5. 5 is less than 3 minus 5. No. So therefore, this is not reflexive. Symmetric, that means if this map to something, say 2 is mapped to 3, then 3 must map to 2. I don't think this is symmetric, right? By look of it, because these are the possible values. Symmetric means whenever x map to y, y map to x. Okay. And this is for all integers. Integers means it goes from here to here. Any value of x. Okay. So this is tough one anyway. I try to look at it from different ways and I try to find a logic. Okay. Because these are range of answers. For example, if plus 2 map to minus 3, then minus 3 map to plus 2. Right? If plus 2 map to minus 3, then minus 3 map to plus 2. But, okay. This is bit of a debate. Okay, this is tough one for me. For the safe side, I like to go for none of the above because, anyway, I'm not very sure. But possibly transitive, or none of above. I know. Anyway, it's confusing for me also, right? Let's see the answer. B, symmetric. So why it is symmetric? That means if A map to B, B map to A also. Anyway, this is the range. If 2 map to 3, 3 map to 2. Symmetric. So this is the mirror image on y equal x. It looks like correct, right? So if this, for example, if 0 map to 3, then 3 map to 0. Right? Yeah, 0 map to 3, right? 0 plus 3 is less than or equal to 3. Then 3 map to 0. Anyway, it looks like correct also, right? mirror image එක ඇතුලේ තියෙනවා නේද මේ mirror image එකේ. මේ point එකක් තියෙනවා මේ point එකක් තියෙනවා මේ point එකක් තියෙනවා මේ point. I think yes. Right? Now it looks like yes. Because this mirror image on y equal x line points are there. If this point is there, this point is there. I think it's fair, right? B is correct. Okay, B is correct. But other things, of course, we can't say, right? Yeah, anyway,
So
answer.
what is the range here?
Sorry?
What is the range here?
So if the domain is all integers, so range must also be all integers because it can go from minus infinity to, because these are all possibilities, right? Minus infinity to plus infinity. So therefore range can also, if the integer domain is integers, the range must also be integers. Okay. But anyway, the question is not talking about the range. It talk about only the reflexivity symmetric. Anyway, it's a tough question for me also, right? But it looks like it's fair to say symmetric because if you look at y equal x line mirror image, if there's a point, there should be the mirror point also. Okay. Right. It's a tough question anyway.
Sir, I can't understand why it is symmetric.
So symmetric means whenever there's something like 2 to 3, there must be 3 to 2, right? So by look of this, you can see when this is y, if I draw the y equal x line, that is where you can get the symmetry. Right. So you can see if there's something like this point, so then there's something like this point is also x because it's a range of values. When this is axis, this is axis. So can you think of a point here and its mirror image on this is not in this range? That means you come up with a contradiction. So that means you find a point, but its mirror image point is not in the shaded area. Can you find such a point? I can't find such a point. That is why I say it's reflexive, symmetric. Whenever A to B is there, B to A is there. So, for example, if this is a point, right, its reflexive point is this right? Say this is 3 minus 8. So then minus 8, 3 must be there. Okay.
Okay.
Okay, it's confusing. Yes, it's confusing, but it looks like my gut feeling says the symmetric point must be also in the shaded area. Okay. Anyway, examiner's answer is also saying that it's symmetric anyway. Right. So it's a tough question. Very tough question. Right. How many relations exist from set X to set Y if set X has 3 and 4 X and set X and set Y has 3 and 4 elements respectively? So that is another tough question, it looks. Okay. Right. So let's draw this. Right. So we have 3 elements here and we have 4 elements here. Right. How many relations, right? How many relations? So relations have no restrictions at all, right? So say this is A, B, C. This is P, Q, R, S. So one relation may be how many relations exist from X to Y? If set X and set Y has 3 and 4 years, one relation may be just this one. No other connections, right? Because it's a relation. But do they say that always there must be mapping? I think they expect that there's a mapping, right? No orphan values. Anyway, this is very unfair sort of a question because so many possibilities are there, right? So I'll go for the biggest value at least, okay?
Sir,
Sorry?
sir, can't we do like combination question? Is it a combination question?
But how many combination? Even none to none is also right. So for example, this is mapped to this, but nothing else is not mapped. Still, it's a relation, right? That is why I told you possibly all of these values must be mapped. All of these values must be mapped. Nothing can be orphan, but in relations, orphan values are also possible, right? So there can be a situation, this is mapped to this, this is mapped to this, this is mapped to this, this is mapped to this. And maybe this is mapped to this, and this is orphan. So then how many possibilities? Then how many possibilities are there? Because it can be one to one, one to many to many. And there can be unmapped values. So, okay. Or can we think of like how many ways 3 elements are mapped to 4 elements? And what is the answer? I will go for the biggest value. Right? I have no clue. No. Yes, the biggest value is 4096. Okay, shall we ask that from ChatGPT because I have no idea. maybe it should be, first we maybe need to restrict, or maybe yes, definitely we need to do it as a combination question, right? There's no other way. Right. I can't use now any of these. Right. But there's a workaround for that also with me. When there's a problem, there's an answer. So let's first convert it to text and then put it to ChatGPT, because ChatGPT is not happy with giving me a lot of images. To how many ways relation exists from set x to set y? We use this formula. Number of relation x to y, 2 to the power x into 2 to the power y. 2 to the power x into y. Maybe you can remember this if they, in case they ask this question again, right? Because otherwise, how can you think of these things in the exams? Okay. Yeah. So
So what is the logic behind that formula?
I don't know. I have no idea. Otherwise, I would have done this question by now. Okay. 2 to the power x into y. I have no idea, but that gives you 4096. Right? 2 to the power x into y. Right? 2 to the power x into y. It's not normal NCR formula also, right? So 2 to the power x is how many ways? For example, now you know that, yeah, this is possible way to think about it. I don't know whether we can get into a conclusion. Uh, right. For example, when I have, right, when I have two variables, how many ways I can arrange them? Say A and B. If we have two values, that is true, false, true, 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 false, false, true, false, false. That is 2 to the power 2, 4 elements. If it is C, we get 2 to the power 3, 8 elements, right? So that is if it is true, false. So that is where that 2 to the power comes. 2 to the power comes. Maybe they think about, when we have this kind of possibility, how many ways we can map. Okay, is it map or not? No, that also not correct, right? Yeah. So this can be mapped or this cannot be mapped. I just try to see whether it's a Boolean. Usually 2 to the power means it's a Boolean concept, true false concept. Using that kind of a condition, you get the answer. Anyway, that also doesn't make much sense to me. Shall we ask ChatGPT, can you explain the logic behind the formula? But for the time being, just remember the formula, okay? Right. So it says yes. So this is something like your Cartesian product, right? Because Cartesian product is all possibilities, right? For example, when we have, say, two, say 1 comma 2 and a comma b, remember 1 to a, 1 to b, 2 to a, 2 to b, right? So Cartesian product. Okay. So he also is Cartesian product. Basically, all possibilities are Cartesian product, right? Uh, right. So this has 3, this has 4. So then all Cartesian product has 12 ordered pairs, right? Ordered pairs. Because first one to the fourth, second one to the fourth, all 4, yes, 4 into 3, 12. Uh, so then, In relation in any subset of these 12 pairs, yeah, any subset of these are relations. Remember, relation is a subset of Cartesian product. So remember the number of subset is 2 to the power number of elements. I think that makes sense, right? That makes sense. I don't know whether you understand it, right? So this is what ChatGPT explained. So when we have, I think that makes sense also. Right. So this is what ChatGPT explained. Okay. So when we know that this one has 3 elements, this one has 4 elements. So therefore, how many ordered pairs are there? Like A to A1 to A1, A1 to A2, A1 to A3, A1 to A4, then A2 to A1, A2 to A2, A3, and so on. So that means we have A 3 into 4 ordered pairs. 3 into 4 ordered pairs. Like this, 3 into 4 ordered pairs. That is your set. Right? But anything is possible. Just one of the, say just A1 to A B1 can be the only ordered pair also. That is subset of this. So all the relations are subset of this. Right? All the relations are subset of this. So therefore, how many subsets we can create? When we have 12, now 3 to 4 is 12. 2 to the power 12. So how many subsets we can create? 2 to the power 12. 12 is from the Cartesian product, 3 into 4. So therefore, how many subsets? 2 to the power 12. So therefore, 2 to the power 12 is 4096. I think it makes sense also, right? It makes sense. Okay. And another thing you can do is you can just think you have only 1 and 2, right? Just to justify yourself that it is correct also. Say you have only one element here, and here you have 2 elements. So then how many possibilities are there according to our formula? 2 to the power 1 into 2. That is 2 to the power 2, 4. What are those possibilities? One is this is mapped to this, right? And this is mapped to this. That is one. What is the other one? This is mapped to this, and this is often. That is second one. Another one. This is mapped to this. This is often. Another one, because we have 4. Nothing is mapped. Can we have any other possibility? Can we have any other possibility? Right? Nothing is mapped.
So
This-
last one is like a factorial 0 is equal to 1.
Sorry?
The last one, no mapping, is equal to 0 factorial is equal to 1.
Yeah, so last one is all for any relation, it is 1. Because there's a possibility that nothing is mapped. Nothing is mapped. Okay. So therefore, those are the 4 possibilities. So therefore, it actually confirmed that that formula is correct. Formula is correct at least for 1 and 2. Then you can check it whether it's for 1, 2, and 2. Because according to the formula, it is 2 to the power 2 into 2. That is 2 into 2 is 4, 2 to the power 4, 16. So you will get 16 possibilities. And one possibility is this. And one possibility is something like this. This is mapped to both, this is mapped to both. And all the other possibilities. So basically, it's all subset of Cartesian product. Cartesian product. Okay. But then I have another doubt here. Cartesian product doesn't have the empty set, right? So then how do you check that? All right, but when we take a subset, we consider the empty set. Yeah, so therefore empty set is also considered. Right. Right. Anyway, it's a tough question, right? I don't know whether we can go to the exams and think about that unless you have think about and go to the exams, right? I have not seen this kind of a question, right, before this paper. Okay. Right. So it's a tough question. Very, very tough question. Okay. Right. 32. So the examiner is more interested in combination and permutation than anything else. Okay. Right. What about this? This should be easy because these are already mapped ones. Okay. I'll draw like X, Z, and Y, right? X, Z, and Y. X, Y, Z. X to Y. X to Z. Z to X. Because this kind of diagrams are easier. Z to Y. Like Z to Y. Which one of the following is true? R is not symmetric. Obviously not symmetric because X to Y is there but not Y to X. But antisymmetric, not antisymmetric also because we have X to Z and Z to X. Right? So therefore this is wrong. Not symmetric is correct, but antisymmetric is also wrong. R is symmetric, correct. Sorry, R is symmetric is wrong, but not antisymmetric. Anyway, this is wrong, right? Because but means and. R is neither symmetric nor antisymmetric. Yes, it is not symmetric and also it is not antisymmetric. R is not transitive. For example, if you take something like we have X to Z, Z to Y, then X to Y is there. Then we have Z to X and X to Y, Z to Y is there. It is transitive, right? It is transitive. Can you see violation of transitive? When you have this to this, we have this to this. When you have this to this, we have this. No, R is transitive. R is not transitive is wrong. R is transitive. R is both symmetric. No, it's not symmetric, right? So I'll go for C. I'll go for C. Oh, C and D. Not transitive. How can we say not transitive? Can we see any possibility of violation of transitiveness? X to Y, X to Z, Z to X, Z to Y. Whenever A to B, I can see B to A. A to B and B to C, I can see A to C. Can you see anything? We have this. We have this. For me, answer is right. For me, R is not transitive is wrong. R is transitive. Right. For me, D is not answer. For me, answer is only C. For me, answer is only C. Okay. So shall we ask from ChatGPT?
Sir, Y is not transitive.
Why it is not transitive? Because it
No,
is.
Y is not transitive.
What do you mean by why?
Y is not mapped to
But
X is mapped to Y, but Y is not mapped to X.
that is symmetry. That is not transitiveness. That is symmetry, right? Whenever, but transitiveness says whenever X to Y and Y to Z, there must be X to Z,
Yeah.
right? But this, whenever X to Y, that means if something is not symmetric, automatically it is not transitive also. If you look at
Yeah,
like,
there is only one possibility.
yeah. So when X is not, so transitiveness says whenever A to B and B to C, there must be A to C. Whenever X to Y, yeah, I think if it is not symmetric, it can't be transitive also, right? According to that logic. That means whenever something is not symmetric, but that is also wrong, right? Because there can be not symmetric but transitive. For example, X to Y, Y to Z, then X to Z. Right? Something like this. X to Y, Y to Z, and then there's X to Z. Now, can we say that it is not transitive? Can we say that it is not transitive? It is X to Y, Y to Z, X to Z. But X to Y, there's no Y to Z. Okay. But anyway, it's a very interesting question you ask it. I, what I thought is we need to consider transitiveness when it involves in three variables or three values, not two values. Okay. Shall we ask that from ChatGPT? I can straight away copy paste, right? Right. So ChatGPT also says that is transitive anyway. So ChatGPT's answer is also only C. Okay. I think we don't need to consider, we consider transitiveness about when we have three variables, right? Three variables. So if it is just you are looking at two things, you don't need to, you basically it's not, you don't need to check the transitiveness because it's when we have three variables, we need to check the transitive. I think therefore, anyway, the answer is ChatGPT also says answer is so what is the answer? Yeah, answer is C, right? C. But examiner's answer has D also. Okay, D also. For me, it is transitive actually. Because usually we check transitivity when we have three variables. Just because there's A to B and no B to A, of course, then so your argument is when there's A to B and B not B to A, it is both antisymmetric, sorry, both not symmetric and also not transitive. But transitiveness is checked when we have three variables. Right. So therefore, I feel like this relation is transitive. So therefore, D should not be answer. Okay. Anyway, you can just have a bit of more chat with ChatGPT or maybe right. Right. 33. Let rho, sorry, P and Q be two propositions. Which of the following arguments is invalid? Right. So this time consuming, but we'll do it because we are at the end of the paper now. Right. P implies, I will use not the truth table, I will use the argument approach. P implies Q, Q, therefore Q. Okay. Anyway, Q has happened. If this is true, right? So this is true. This is anyway true. Right? P implies Q. Q has happened. If Q is true, Q is true. So argument is valid means whenever all are true, this is true. But this is true means that is good enough to say this is true. Right? So therefore, this is definitely valid. Valid. Okay. Valid means we can't challenge this because Q has happened. Q has happened. And Q has happened means yes, Q happened. Okay. Actually, this is not relevant, but anyway, this we can't challenge now. Right. So next one. P implies Q, not Q, therefore not P. Right. So we can always take both as true. Start with simple ones. Not Q is true means Q is false. So that means this is false. When this is false, for this to true happen true, this must be false. This must be false because if it is true, this is false. So for make this argument, this statement to be true, this must be false. Remember the word must be, right? Not can be. Must be. P must be false means not P must be true. Not P must be true. So therefore, this is true because this is true. Yes, must be true. Okay. POQ, POQ, not P, therefore Q. Again, we take both true. So not P is true means P is false. When P is false, For this to be true, Q must be true. Yes, Q must be true. So that means this is yes. Right. POQ, this is true. Right. POQ is true, therefore P. Now, for this to be true, now this is true, but this can be true when P is true and P is false also, because when P is false, so Q can be true. So therefore, P can be true or false. True or false means this can be valid or invalid. So therefore, that is not good enough. Right? P and Q, therefore P. So this is true. This is true when both are true only. This is true when both are true. So both are true means P must be true, Q must be true. So P must be true is what we are telling. So therefore this is correct. So the valid arguments are A, B, C, and E.
The question is about invalid arguments.
Yes. Sorry for that. So therefore answer is D. Right? Answer is D. Right. Pay attention to that also. So which one is invalid? So therefore answer must be D. Answer must be D. Yes, answer is D. Sorry for that. Okay. So when you going for the exams, the first thing you need to keep reminding is pay attention to whether true or false. Especially remember the web development paper also they had done it, right? They had done it. Maths paper they do it. Okay. Yeah. So therefore answer is D. Okay. Right. Union of events A and B is the event containing union of events A and B. That is A or B. A or B. All the sample points common to both A and B. No, that is not union. Common means sort of intersection, right? Common to both A and B. That is this side. So all the sample points belong to A or B. Yes. All the sample points not belong to A or B. No, that is this. All the sample points belong to A or B or both. Correct. Belong to A or belong to B or both. Okay. All the sample points belong to A or B but not both. No, that is exclusive of. I'll go for B, D, B, D. Or B is not taken. Why is that? All the sample bit points maybe because this is duplicated there. Because they don't tell that it is a set. If it is a set, correct. Because set doesn't have the duplicate. Maybe examiner is looking for very precise answer. All the sample points belong to A or B. So maybe examiner thinks that there's a duplicate double count in there. So I think this is more precise. All the sample points belong to A or B, but this says O both, right? Oh, but this say O both. A or B or both, but this say belonging to A or, but this is perfectly okay now, right? I thought the examiner want to eliminate the double counting, right? So then, I don't know. This is very fuzzy answer. Shall we ask that from ChatGPT again? Anyway, it's all about wording, right? All about wording and your interpretations. But maths paper, why they are doing that kind of fuzzy? Right? For me, both two answers are correct. Yeah, you can see D, all the sample points belong. No. Examiner, ChatGPT also said D. Okay. Also tells A. Because ChatGPT always bias towards one answer because ChatGPT sometimes assume only one answer is correct. right? Because when multiple answers are possible, actually, okay, let's say multiple answers are possible. Check whether ChatGPT changed the mind. Oh, now we can see ChatGPT says B is also correct, right? Right. So ChatGPT assumed that it is single answer is correct, so therefore went for the best. Now ChatGPT says, okay, then B is also correct. Okay. Right. Anyway, that is a rare debatable question, right? So these questions were tough, but this is a debatable one. Okay. Right. 35. If A is a subset of B, if A is a subset of B, uh, conditional probability B given A is, right? B given A. So A is a subset of B. It's proper subset of B actually. Right? A is a proper subset of B. Probability of B happening given A has happened. Right? Probability of B happening given A has happened. Now, if A has happened, our sample space has only the element of NA, right? Because A has happened. Okay, A has happened. Uh, so therefore, our sample space has number of elements in A. Okay. Now, what is the probability of B happening? Right? A has happened. If A has happened, right, these things cannot be happen. These things cannot be happen because A has happened, right? So therefore, if A has happened, what is the number of possibilities for out of the B to happen? Again, number of elements in A, because all the elements in A are in B. So therefore, it's again A, right? Because A is a subset. A has happened. So when A has happened, what is the probability of B happening is then 1, right? Because whenever something in A happens, B has also happened, right? A වෙලා තියෙන හැම වෙලාවෙම B වෙලා තියෙනවා. මොකද B ඉන්නේ ඒක B ගේ ඇතුළේ නෙයි. So therefore probability is 1. It's something like asking if you are in the room, what is the probability that you are in the house? Of course, if you are in the room, you are always in the house because room is inside the house, right? So the answer must be 1. Right? Answer must be 1. Yes, A 1. A coin is tossed and dice, it must be dice, okay, is rolled. Find the probability that coin shows tail and die shows an even number. These are the classic questions, right? Right. So coin is tossed, head, tail. And here we have 6. 1, 2, 3, 4, 5, 6. And again we have 1, 2, 3, 4, 5, 6. And all the probabilities are half into 1/6. All the probabilities are 1/12. And out of which are going to satisfy this? Coin shows tail, that this is outside now, out. Even number. Even numbers are 2, 4, 6. That means everyone is 1/12. So we have 3 such scenarios. There is 1/12 plus 1/12 plus 1/12. Because this scenario is out now. From this scenario, all our probabilities are 1/12 because 1/12 half into 1/6. And only 2, 4, 6 we need to consider. So 1/12, 1/12, 1/12, 3 out of 12. If 3 out of 12 is answer, nothing else can't be answered. B. Right. At least the probability question looks so far easy. What is the missing joint probability? Now, this is a very famous question. You may have seen this type of questions over and over if you have done a lot of past papers. These are මේක දැක්ක ගමන් ඔයාලට ඔළුවට එන්න ඕනේ මේ වගේ past papers වල තියුණා කියලා. හරි. What is the missing joint probability value shown by question mark on the tree diagram shown below? Right. Okay. So this is 0.2 means this must be 0.8. 0.8 means 0.8 plus 1/12 plus 1/12 plus 1/12. 0.8 plus 1/12 plus 1/12 plus 1/12. 0.8 plus 1/12 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 plus right? Because probability must be, if this is 0.2, this must be 0.8, right? And if this is 0.3, this must be 0.7. So then what should be this value? 0.8 into 0.7, right? .56. D. D. It's a common question, okay? A box containing 3 red marbles and 2 green marbles. 3 red, 2 green. 3 marbles are drawn at random without replacement. So that is easy, right? Not conditional probability, independent events. Still we can multiply. What is the probability that 2 marbles are red, 1 marble is green? Right? So you take how many? 3 marbles. 3 marbles. So that means we have 2 like this, another 2 like this, and another 2 like this. Those are the all possibilities. Red, green, red, green, red, green, red, green, red, green, red, green, red, green. And all are, we can calculate the values later. So anyway, let's write it. 3 out of 5, 2 out of 5. 3 out of 5 because we replace. Okay. Sorry, without replacement, right? Without replacement. So that means not 3 out of 5. That means it's already red. So that means 2 out of 4. This is 2 out of 4 because green marbles are already there. This is, still we have the 3 red marbles, but 4. Now green marble is used, 1 out of 4. Now this is both red, 2 reds are already used, 1 out of 3. 2 out of 3. This is 1 red and 1 green is used. 2 out of 3. 1 out of 3. Okay. So green and red is used. Now this is red. 2 out of 3. Green 1 is used. 1 out of 3. Both green are used. This is 3 out of 3. And this is 0. Because both greens are used. Right. So what we need is 2 marbles are red and 1 marble green. 2 marble red, 1 marble green. This is one possibility. 2 marble red, 1 marble green. This is another possibility. This is another possibility. 2 marble red. No, there's no other possibility, right? Because this is only 2 green marbles. Right. We just need to sum these 3. This is 3 by 5 into 2 by 4 into 2 by 3. This is 3 by 5 into 2 by 4 into 1 by 3. And this one, 2 by 5 into 3 by 4 into 2 by 3. Always what we get is 20, 20 into 3, 60s. This is 3 into 2 into 2 is 4, 4 into 3 is 12. 3 into 2 is 6. 2 into 2 is 4, 4 into 3 is 12. 30 divided by 60. That is 0.5, right? 0.5 is not there. How comes that? Did I make a mistake? 2 marbles are red and 1 marble green. Red, red, green, this one. Red, red, green, this one, correct. Red, red, green, this one, correct. And there's no other red, red, right? 3 out of 5, 2 out of 4, 2 out of 3. 3 out of 5, 2 out of 4. This is 2 out of 3, right? Yeah, this is 2 out of 3. So that is 12, right? This is also 12. So 12, 12, 12, 36. 36 divided by 60, right? That is 10. 0.6. Answer is E. E. At 39. 2 dice are rolled. Probability of getting total 4 given that both phases are similar is. Right. Both phases are similar. Two dices are rolled. Two dices are rolled. Probability of getting total of 4 given that both phases are similar. What are the possibilities of both phases are similar? 1, 1. Right? 2 dice. 2, 2. 3, 3. 4, 4. 5, 5. 6, 6. So my sample space has only these. How many elements? 1, 2, 3, 4, 5, 6. NS is 6. Because now conditional probability. And getting total of 4. Where do we get 4? This one we get 4. There's no other way you can get 4, right? Because the total must be 4. Only one. These are the possible conditional probability values. So out of those, only one possibility is satisfied this. 1 out of 6. D. D. So that is conditional probability. Right. 40. Company A produces 10% defective products. Company B produces 20% defective products and company C produces 5% defective products. If choosing a company is equally likely an event, then find the probability that the product is defective. So this is something like this. So why can't I draw now? Just give me 1 minute. I have trouble drawing. Okay, let me close and open it. Okay, 2022 paper. Let's check whether I can draw now. Yes. So this is something like this. We have 3 companies, A, B, C. It's exhaustive because it must be either A or B or C. A or B or C. And this is defective or not defective. Right? So defective, not defective. Okay. Probability of A is 0.2. Probability of probability of ABC is 1/3, 1/3, 1/3 because equally likely. Probability of you select item is A is 1/3, PB is 1/3, and PC is 1/3. Okay. Now, this is defective. Okay, so this is defective. Probability of this is D. Probability of defective given A is 10%. Right? That is 0.1. Probability of defective given B is 20%. 0.2. Probability of defective given C is 0.5. Now, question is find the probability that the product choose is defective. Probability of D. Right. Probability of D. Apa use kan pelambad? Let me open the probability note. I can't remember the exact formula. Mathematics. Probability. At the end. Right. Total probability law, right? Probability of B happening. Right. Now B means defective. So that is probability of B given A1 into probability of A1 plus probability of B given A2 into probability of A2 and blah, blah, blah. Okay. Right. So therefore, formula must be probability of D given A, probability of D given A into probability of A. Probability of A plus probability of D given B into probability of B plus probability of D given C into probability of C. And we have probability ABC, we have probability D given A, D given B, D given C. That is, anyway, probability of A, B, C are all 1/3, so therefore I can take that out. Then probability of D given A, D given B, D given C, you need to add 0.7, 0.8. 0.8 into 0.3. Okay. 0.8 divided by 0.3. These are decimals. Okay. So let's divide 0.8 by 0.3. 0.8 divided by 3. 2, 6, 20, 6, 18, 2, 6, 6, 6, blah, blah, blah. But there's no such answer, right? There's no such answer. This is correct. 0.1, 0.2. This is 0.05. Sorry, this is not 0.5, this is 0.05, right? 5% is 0.5. So therefore, this is 0.2, 0.1, 0.3, 0.35. Right? Not 0.8, 0.35. Right? 5% means 0.5. So 0.35 divided by 3. 1, 5, 1, that is 3, 20, 6, 1, 1, 6, 6, 6, 6. So 1, 2, 0.12. Right? 0.11 is also there, but because this is more closer to 0.12, I'll go for B. I'll go for B. Yes, answer is B. It's total probability law question. Or you can write it as a conditional probability also. Using tree, probability tree. Because this is selecting A, selecting B, selecting C, that is 1/3, 1/3, 1/3, then whether it's defective or not. Defective or not. Defective or not. So then you need to add these defective. ඇත්තටම ඔය තුන තමයි add උනේ. ඔය තුන තමයි add වෙලා තියෙන්නේ. ඔය තුන තමයි add වෙලා තුනෙන් එක වැඩි කිරීම defective වෙන එක, තුනෙන් එක වැඩි කිරීම මෙයා defective වෙන එක, තුනෙන් එක වැඩි ඔයාලට කැමති විදිහකට හදන්න. හරි? කැමති විදිහකට හදන්න. Right. So we skip 2 questions, right? ඒ question දෙක පොඩ්ඩක් බලමුද? question ටික. skip කරන්න යන්නේ question වගේ.
Yes, 19th one.
19th.
Yeah.
Yeah, 19th. Let A be set. Oh, that is a tough guy. How many surjective functions? Let A be set with n is greater than 2. And B set with 2 elements. So this has only 2 elements. But this one has n elements, which is bigger than 2. Like 1, 2, 3, 4, and so on. How many onto or surjective functions are there? Onto means no open values in the range. Okay. But this is definitely more than 2. So the next possibility is 3. Onto functions. So how many possibilities are there? Now can we think of like the Cartesian product is our possible relations, right? But this is function, right? So therefore you can't have many to one to many. You can't have one to many. You can't have many to many. Anyway, let's keep that for the time being, right? Nothing comes to my mind right now. Okay, right. So did we skip another one? Because my
27.
27. Let A be this to this. How many one-to-one functions can be defined from A to B? Right. So that is also a tough one. So examiner is very interested in combinations and that kind of things, right? How many one-to-one functions? Right. So this is A, B, C, D, and this is 1, 2, 3, 4, 5. And it must be functions. Function means you can't have open values here, but you can have open values here, right? Because it's not, they are not saying on to function. They just say function, right? So something like this is possible, obviously, one to one. But then how many possibilities are here? Because we can swap this, right? A become here and so on. So how many Cartesian ordered pairs are there? 4 into 4, right? 4 into 4. But then we can take this and eliminate another one. How many one-to-one functions? Right. So here we have 4 into 4 possibilities, visibility, right? So here we have 4 into 4 possibilities of functions, right? Because one possibility is this. Another possibility is basically you take all the ordered pairs, right? So then 4 into 4 number of ordered pairs are there, right? All are one-to-one. And so let's think like that. Let's assume we map this to this. Then this can be mapped to 3 possibilities. Sorry, 4 possibilities are there. Right. So let's try to do like that. Right. So this one, let's say we map to this. That is only one. So then how many possibilities for B? 1, 2, 3, 4. Right. 4 possibilities are there for this guy. For this guy, then 3 possibilities. Because now this one has been mapped to another one. Now there are, say this one is mapped to this. Now this one has 3 possibilities. Right. And this one has 2 possibilities. Last one has 2 possibilities because this is now you have the possibility to map this or this. Okay. First one has 5 possibilities. 1, 2, 3, 4, 5. Once the first one is mapped, second one has 4 possibilities. Third one has 3 possibilities. Last one has 2 possibilities. Okay. Possibilities. So that might be one possible answer, but I'm not 100% sure. There is a bit of a logic. First one has only have 5 possibilities to pick. Then one of these is already picked. The second one has 4 possibilities, and so on. If so, the answer is 20 into 60, 120. 120 is there anyway. Uh, does it make sense? I don't know. I'm also not 100% convinced about my answer, but some sort of a logic, because something is better than nothing. Okay. By the way, what is the answer? Yes, answer is D. By the way, I'm not also 100% sure whether that is the correct way to get the answer, but I got the correct answer, and it's bit of logic is also there, right? So first one, I have 5 ways. Now, when the first one is already mapped to something because it is 1 to 1, for the second one, I have 4 ways. For third one, I have 3 ways. For the last one, I have 2 ways. Okay. So shall we ask ChatGPT also and see whether ChatGPT come up with a better explanation? Now the answer is correct anyway, but it can be coincidence also, right? We'll straight away ask to calculate without giving answers. Okay. 1 to 1. It looks something other way. So that is out of 5, how many ways we can take 4 permutation, arrangements. This is not combination, right? Arrangements. Then of course, out of n, how many ways you can take and arrange m number of things. Okay. So that is factorial n divided by factorial minus n. Factorial 5 divided by factorial 120. Does it make sense? Out of m elements, out of n elements, how many ways we can arrange m elements? Out of n elements, how many ways we can arrange m elements? Linearly. Anyway, I'm not very sure about that also. Okay, anyway, so did we skip any other question? Because that is the best I can explain. I don't think so, right? One question I told you that we will not do that, okay? Right, so yeah, that's it about 2020. Actually, that paper is tougher than 2023 paper, right? So now shall we do the rest of the 2022 paper? Sorry, 2023 paper, right? Because that paper is much easier, right? Much easier than 2022 paper. Right. So now we have done 2022. We want to finish 29 onwards. Like 29 onwards. So remember you have the afternoon session. Right, 29 onwards. Right. Right. 29 onwards, right? Yeah, 29 onwards.
Sir, we didn't do sixth one.
Fifth question.
Sixth.
Yeah, that will come back later. Right. 29. Let R be a binary relation on the set of positive integers Z, positive integers, that is 1, 2, 3, 4, and so on. Define on N to M real numbers if and only if N divides M. Right? If and only if N divides M. So we are going from N to M. Okay? Right. So N to M. N to M. Right? And these are positive integers 1, 2, 3, 4, 5, 6, and so on. But the relation exists only if N divides M. N divides M. That means 1 divides everything. So 1 divides everything. Right? Positive integers. 1 divides 1, 1 divides 2. No, right? 1 divides. So we can say 5 divides 10. 5 divides 10. Or 10 is divisible by 5. 5 divides 10. But 5 doesn't divide 11. But 1 divides everything, right? Yeah, 1 divides everything. That's a very special case. Then 2 divides 2. 4. Okay, let's use a different color. It's a tough question. Right, 2 divides 2. 2 divides 4. 2 divides 6 and so on. So then 3 divides 3 and 3 divides 6 and so on. Okay. Right. Now let's read the question and see at least we can find some answers so that we can collect some marks. So definitely 1 is mapped to 1, 2 is mapped to 2, 3 is mapped to 3, 4 is mapped to 4 because it divides itself. So therefore I'll definitely go if there's something called reflexive. Right? Reflexive I'll go. Reflexive I'll go. Okay. Right. Can I say symmetric? If 2 divides 4, does it say 4 divide 2? No, right? Maybe 3 divides 9, but 9 doesn't divide 3. So therefore I'll not go for symmetric. Right, symmetric. Right, symmetric. Because it is not symmetric, I will not go for equivalence. Okay. Right. So now I have eliminated 3 answers. Is it transitive? Is it antisymmetric? If 2 divides 3, does 3 divide 2? No, right? Because one is bigger, other one is smaller. If 5 divide 15, 15 doesn't divide 5. Okay. So therefore, I don't think that it is antisymmetric. Antisymmetric means, yeah, and it is antisymmetric, right? If 5 divide 10, 10 doesn't divide 5. So this looks like okay for me. Antisymmetric. Remember, when we look at antisymmetric, we forget about the reflexivity. Right? Right. Transitive. If 2 divide 4 and 4 divide 8, then 2 divide 8, right? For example, 2 divide 4, 4 divide 8, then 2 divide 8. Right. Let's take another example. 3 divide 6, 6 divide 12, and 3 divide 12. Let's take another one. 5 divides 15, 15 divide 30, then 5 divide 30. For me, it's transitive. Okay? For me, it's transitive. So therefore, I'll go for D. Yes, answer is D. Tough one, but you get these kind of questions almost every year. Okay. So how quick your thinking is. Right, 30. Is it clear? So I just took some examples and see whether there are contradictions. Because there's no other way I can think, right? I can't think in the abstract level like this. Right. Only way is look at some possibilities. Right, 30. Let A and B, which of the following relations from A to B is not a function? Oh, that should be easy. That should be easy. Right, if it is a function, every value in the domain must be mapped. That is number one. Okay. No orphan values in the domain side. So can we see the orphan values? 1 is there, 2 is there, 3 is there. But here 3 is not there. So that means 3 is not mapped. So therefore this is not a function. What we are looking for is not a function anyway. Right. So that first condition is satisfied by others. So this one is not a function. Second condition is functions are either one-to-one or many-to-one. It can't be one-to-many. If there's one-to-many, that is not a function. Right. See whether there's one-to-many. 1, 2, 3, 1, 2, 3. Sorry. 1. No, right? Nothing. Nothing. So therefore, these are all one-to-one. 1, 3, 2, 4, 3, 4. 1, 2, 2, 3, 2, 3, 5. This is 1, 4. 1 is mapped to 4 and 2 is mapped to 4. But that is fine. That is one to many. And 3 is also mapped to 4. That is fine. And you can have orphan values in the range side. Function can have orphan values in the range side. But you can't have orphan values in the domain side. So this is fine. And none of these are one to many. None of these are one to many. So therefore, I'll go for D. I'll go for D as a not a function. Yes, D. Okay. So this paper is, I mean, if you know the theory, this paper is easy. There's no doubt about it. Right? If you know the theory and you have reasonable logical thinking, the 2022 paper, you can't survive with your theory. You need to think fresh at that point. Sometimes you need to build theories also. Okay. Right. Because the rest of the questions also we discussed, right? Those are not that tough. In how many ways one can select 2 children out of 3 boys and 3 girls? These are the textbook questions. Right? Textbook questions. Right. So we have 2 children. We have 3 boys. 3 boys and 3 girls. 3 boys and 3 girls. Out of those, we need to pick 2 children. Now remember the word is 2 children. 2 children, not 2 boys, 2 girls. All are children. Boys and girls, all are children. So therefore, we don't care whether it's boys or girls. Actually, we don't care with the boys. Just this is unnecessary or sort of extra information. So basically, what we need to think is we have 6 students, right? We have 6 children. How many ways I can pick 2? And 6 students, they are different students. So out of 6, how many ways I can take 2? Because there's no condition saying there must be at least 1 boy. No, there's no such thing. Just we don't consider whether it's boy or girl, but we just consider there are 6 different children. So that is NCR question. 6C2 factorial 6 divided by factorial 6 minus 2, 4 and factorial R. Right. So then 6 into 5, then rest of the stuff cancel out. And then 2. 15 ways. 15 possibilities. E. Yes, E. So these are actually, this is to confuse you. they have given boys and girls because they don't restrict. There are no restrictions on number of boys and girls in the selection. Right, 32. If z to z be a function defined in fn n squared, then z is the set of all integers. Right, so let's try to build this. Right, this is z to z, integers to integers. The integers can be negative numbers, right? -3, -2, -1, 0, 1, 2, 3. -3, -2, -1, 0, 1, 2, 3. Right? Z to Z. And the function is fn is n squared. Fn is n squared. So that means 1 is 0 is mapped to 0. 1 is mapped to 1. 2 is mapped to 4. 3 is mapped to 9. -1 is mapped to 1. -2 is mapped to 4. -3 is also mapped to 9 and so on. Okay. Right. So therefore, shall we draw it properly? So this is our function now. Zero is mapped to 0. This side is anyway all are positive numbers. Okay. So therefore, let's change it. So this can be -3, -2, -1, 0, 1, 2, 3. -3 is 0 is mapped to 0. -1 and +1 is mapped to 1. -2 and +2 is mapped to 4. Right? And -9 and -3 and +3 is mapped to 9. Right? That is my, but here we have -1, -2, -3. Right? Some of these are not mapped, like 2, 3 is not mapped. 5, 6, 7, 8 map, not mapped. Right? 2, 3, 5, 6, 7, those are not mapped. 10. Right? F is a injection function. Actually, it must be injective function. It is not injective. It is not 1 to 1. You can see it's many to 1. -2 is also mapped to 4. +2 is also mapped to 4. It's many to 1. Right? It's not 1 to 1. If it is not 1 to 1, right, then is it surjective? No, because there are some unmapped values like 2 is not getting mapped. 3, any negative numbers are because your integers is your set. So therefore, it is not onto function. If it is not injective and surjective, it is not bijective, right? F is neither injection nor surjection. Yes, it's not injection and no injective or surjective. Correct. Has an inverse. Of course, every function has an inverse, right? Every function, every relation has an inverse, but okay. But whether its inverse is a function is a different story because this is many to 1, its inverse is not a function. It has an inverse, but its inverse is not a function because inverse is 1 to many. Because 1 is mapped to -1, 1 is mapped to 1. But this doesn't say f has an inverse function. It just say f has an inverse. Of course, I will say f has inverse because it doesn't use the word function. I'll go for D and E. So that is very unfair. F has inverse, it should be, yes, f has inverse. Right? So that is very unfair way to tell it. Okay. Anyway, examiner has not taken E. Okay. That is very unfair. Okay. So I can't put it into ChatGPT because I have run out of resources. Right. Let's see. So this should be n squared. P is correct. So that is unfair also. ChatGPT also say no inverse. Not bijective, therefore no inverse. But actually it has inverse, but inverse is not a function. Right? ChatGPT is also going to the examiner's thing. Okay. So shall we challenge ChatGPT? Why this function does not have, maybe the ChatGPT also interpret as have an inverse function. Okay. The function have a real inverse. Yeah, it's just saying that it is not because it is bijective, it is not a, right? Yeah. Simply it says that it doesn't have an inverse function. Okay. Inverse function. Right. So basically you can also use that terminology. If a function doesn't, its inverse is not a function, you can say that it doesn't have inverse. Okay. Because that is what ChatGPT also use. Right. 33. Let A and B be two sets within 3 and 4 elements respectively. Within 3 and 4 elements respectively. A and B be two sets with 3 and 4 elements respectively. The number of injective mapping that can be defined from A to B is, right? So this one has 3 elements. This one has 4 elements. Right? 1, 2, 3. This one has 1, 2, 3, 4. So injective means 1 to 1. Injective means 1 to 1. Okay. That means how many 1 to 1 mappings? Okay. That is again sort of a selection question. Okay. Selection question. Right. So let's see, we can map. So how many ways I can map this? First one, 4 ways. Because I can map it to any of these 4, right? So therefore I have 4 ways to map the first number. We have 3 numbers, 3 values. Then how many ways I can map the second value? Because only one value is mapped. One value is mapped. Let's say it's mapped to 1. First one I have 5 ways. 1, 2, 3. First one I have 4 ways. Second one I have only 3 ways because this is already the map. Okay, already mapped. Say this is mapped to this, but it can be anything. Now for the third one, I have 2 ways. Okay. I think I use the same logic to do the 2022 if there was almost same question, right? So I'm just using the same logic because it worked for that question. So then how many injective mappings are there? 4 into 3 into 2. 12 into 2, 24. Is it correct? Let's see. I hope it's correct. Yes, 24A. Right, A. Answer is correct. So if you get that kind of a question, maybe that is, I don't know whether there are different ways. Actually, ChatGPT use slightly different notation like NC notation, but I think this work. So how many ways I can map my first one? 5 ways. 4 ways. Second one, only 3 ways because first one is already occupying another value because these are 1 to 1 and so on. Okay. Right. 34. If the union of two events constitutes, sorry.
Today are we having afternoon session?
Yes, we are having afternoon session. Maybe we can do another database, and also we need to do S double AS essays that is related to styling. Yeah, we are going to have another session, maybe around 2. Okay, yeah, maybe 2.
Okay, sir.
Yeah. If the union of the two events constitute, because I try to finish today itself, maybe Monday session, maybe then it's purely optional session for any of clarifications, okay? So that you can start concentrating on your studies. If the union of two events constitutes the sample space of the experiment, then the two events are called. So if it takes the entire sample space, you can see constitute the sample space. That means we call them exhaustive events because it cover entire sample space, right? Exhaustive events. D. Yes, D. 35. 3 unbiased coins are tossed. What is the probability of getting most one tail? Right? 3 unbiased coins are tossed. So the possibilities are you can get head, 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 head. Right? So then getting at most one tail. This extreme is getting all tail. And if it is not head, 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 all the other possibilities you have at most at most one tail. Sorry, at most one tail. At most one tail means exactly one tail, right? Or no tail or one tail, right? So that means this is one possibility because you have at most one tail. Other possibilities are you have only one tail. That is, tail is here, others are head, right? So these are the other possibilities, okay? This is possibility, at most one tail. This is another possibility. This is another possibility where you
So
get a,
it's three unbiased coins, right?
sorry?
It's three unbiased coins. I think you have considered 4.
Yes, sorry. Sorry, 3, 3. That make it even simpler. Right. So this is one possibility that satisfy this. This is another possibility. This is the last possibility. So in these 4 possibilities, we have at most one tail, not more than one. Not more than one. So therefore, we have 4 possibilities that satisfy this. Then what are the all together? How many possibilities? Because we have head, head, head to t, t, t. 2 to the power 3 possibilities. All together, we have 2 to the power 3 possibilities. Right? Because it's sort of a Boolean. But out of those 2 to the power 3 possibilities, these 4 situations satisfy this. So therefore, my answer is 4 divided by 2 to the power 3 is 8. Right? Half. Half. Okay. Is it correct? Should be, right? Yes, A. A. Right, 36. A bag contains 5 black and 3 white balls. 5 black. Now you can see all of a sudden this paper is standard paper. Right? Question can be difficult, but coming from the standard questions. Okay. 5 black, 3 white, 2 balls are picked at random. What is the probability that both are the same color? Right, so we have 5 black and 3 white. What is the probability that both are the same color? So we take 2 balls, right? Yeah, 2 balls. So then I can even draw because this is black, this is white. Okay. So then again, black, white, black, white. We take only 2. Right? So we have 5 blacks and 3 white, 2 balls. What is the probability? Yes, probability. So this is first one getting black is 5 out of 8. First one getting white is 3 out of 8. And do they say we put it back? Bag contains 5 black and 3 white. The balls are picked random. What is the probability that both are? I hope this means we don't put it back because they have not mentioned that we are putting it back. Okay, because we just pick randomly. So then I will say this is 4 out of 7, 3 out of 7. This one, 5 out of 7, 2 out of 7. Right, both are same means black situation and white situation. So these can be added. So that is 5 divided by 8 into 4 divided by 7 plus 3 divided by 8 into 2 divided by 7. 20 out of, but they have not given it as a simplified answer. Okay, so there you can see examiner is more interested in doing this as a NCR question, right? So the probability they asked, but the probability also examiner asked as NCR. That is the issue now. Maybe then we need to calculate this and find the answers. Oh, can we check whether are there any possibility? So this is basically how many ways we can take 5 out of 8, right? 5 out of 8. Because black. Now that is a headache. That is another headache. Now the answers are in. Anyway, let's simplify this and see what is the answer first. 5 into 4 is 20. 3 into 2 is 6. 8 into 7, 48. 56. 26 divided by 56, right? So therefore, this is not an answer. Now, this is 5C1 is, NC1 is N, right? Factorial 5, factorial 1, factorial 5 minus 1, 4. That is 5. This is 5. This is 3. 5 into 3 is 15 divided by 8C2. Factorial 8, factorial 6 divided by factorial 8 divided by factorial 6, factorial 2. I don't think this is an answer. Okay. So just check the answer and I don't know, is there another way? But it looks like these two are not answer. Maybe one of these three. Let's check the answer and double check whether that answer gives this. Okay, at least. Right, 36. Yes, answer is D. And let's see whether the answer D gives us 26 divided by 56. 5C2 is factorial 5. Can we see any logic? 2 out of 5 divided by 2 out of 8. I don't know. I have no clue. Right. Factorial 5 divided by factorial 2 divided by factorial 3 and that divide by factorial 8 factorial NCR is factorial n divided by factorial r divided by factorial n minus r, right? Yeah. Factorial 8 divided by factorial 6 divided by factorial 2 plus factorial 3 divided by factorial 2 factorial 1 factorial 8 factorial 6 factorial 2. You need to simplify and see whether you get this. Okay. Anyway, I don't know why examiner has put it like this. Right? So, but the way we did it is correct. Okay. But unfortunately, the answer is in NC. Okay. Right. So this is an easy question. This is another model question. If you have done past papers at least for another 5-6 years, you may have seen these kind of questions. Right. So it says PA equal half PB. And mutually exclusive and exhaustive events. Right. So that means those events are like this, A and B. Mutually exclusive and exhaustive A, and we cover the sample space. So therefore, PA plus PV must be 1. These are model questions. If it is mutually exclusive and exhaustive, probability summation must be 1. So what we need is PA. So therefore, I'll take PB as 2PA. Right? So then PA plus, from here PB is 2PA. 1. So 3 times per probability of A is 1. So that means probability of A is 1 out of 3. B 38. X and Y are two random independent events. Okay. It is known that Px is 0.2, Px union Y bar is 0.8. Which one of the following is the value of Py? Okay. If X and Y are independent events, By the way, if it is random, independent, Px intersection Y is Px into Py. That is rule. And still we can use Px union Y is Px plus Py minus Px intersection Y. That we can use. Right? So that is why I applied here. I applied Px union Y bar as Px into Py bar in minus Px intersection Y bar. Okay. Px plus Py bar minus this, right? And this is given 0.8. Px is given 0.2 plus Py bar. Yes, that is 1 minus Py. Then this one. This one is minus
This one.
Px into Py bar. Py bar is 1 minus Py. Right? Px into 1 y by Py bar is 1 minus Py. Because this multiplication, okay? 0.2, 1 minus Py minus Px into Py bar, that is 1 minus Px. What we need is Px. No, what we need is Py, right? Right. So this is Px into 1 minus Py. And now we have the Px also. So 0.8 equal 0.2 plus 1 minus Py minus Px is 0.2 times 1 minus Py. Okay. So then 0.2 I can take to other side. 0.8 minus 0.2 is 0.6. 1 minus Py I can take a block. 1 minus 0.2 is 0.8 times 1 minus Py. 1 minus 0.2, okay? So 1 minus Py is 0.6 divided by 0.8, 6 divided by 8. Then Py is, I will take this to the other side, 1 minus 3 divided by 4. Right? So that is 1 minus 3 divided by 4 is 1 divided by 4. Is that the answer? Yes, right. I think that is the answer, right? Yes, correct. Okay. Right. 39. Company A produces 10% defective product, company B produce, I think this is the same question, right? Right. So this is the same question, exact same question, maybe I think exact same question and maybe exact same values also. Find the probability that product chosen is defective, right? Yes, exact question, total probability law question, right? So I'm not going to do that. I think the numbers are also same. Right, what about the next one? Suppose box A contains, that is the advantage of doing more and more past papers, okay? Suppose box A contains 4 gold and 5 silver coins and box B contains 6 gold and 3 silver. The coin is chosen randomly from a box and placed in box B. Finally, a coin is chosen random from among those now in box B. What is the probability of silver coin was transferred from box A to box B given that coin chosen from box B is gold? That should be a terribly difficult question for me. Okay, let's see what happens. Choose a box. Suppose box A contains 4 golds and 5 silver. And box B contains 6 gold and 3 silver. Okay. Coin is chosen random from box A and place it in box B. Finally, a coin is chosen at random from among those now in box B. This is your step number 1. This is your step number 2. What is the probability a silver coin was transferred from box A to box B? Given that the coin chosen from box B is gold. Okay. From here you got a gold. What is the probability this is going from here to here is a silver? Okay, what kind of question is that? Right. I will just keep that question open for the time being because maybe I can think about it in the lunch hour if I have time. By the way, what is the other question we skipped? Anyone? The last time? No one? Right. So I'll have a look at it. Maybe we can try to do another maths paper if we have time. Okay. Maybe today or maybe Monday. Okay. Right. So the evening session, first I want to do another database paper and also another web paper. That is my first priority. So then maybe Monday, in case you need or only those who really need can join, we can do another maths paper. Okay. Right. So we'll start the afternoon session. We'll start at 2 because now it's almost 12:30. And I will give you another invitation for that. Right. But we start at 2. Okay. Right. So I'll stop the session and give you another invitation. Okay.